and I'll transfer over host ship. I'll give it to Brian, and then you can decide what to do from there.
Cool. Thanks.
All right, thank you. Right. So, Mary Beth, your co-host now, if you wanted to try recording to your computer as well, just so that there's a ton of recordings in case something goes wild.
I think my computer might explode if I try to record at the same time.
All right, well, if that's the case, then
yeah, kind of don't want to risk it.
Yeah, don't worry then. Oh, are you recording, Raleigh?
Yeah.
Okay, I'll start too as well then.
Well, I guess if we give people another minute or so to arrive, then we can get started.
Hi, Mary. Hi. I have a question before your talk. So I am curious. So does pizza go bad? Because I think I heard at one point that there was some pizza in the vicinity that got bad. I'm still curious to know.
I believe pizza can go bad, and so does the I think National Food Safety or the Food and Drug Administration in the United States. They believe that too. My partner doesn't eat pizza that had been sitting out for a really long time and survived. So
I see. So it's still an open question.
I think it depends on like how strong your stomach is. I think if I ate bad pizza, I would be very sick. My partner can eat seemingly anything.
Got it. Okay, that's good to know. And I think is it the US FDA that also deems pizza to be a vegetable?
I think that was Congress at some point for unknown
reasons. Okay.
Yeah, I mean, I'll take it.
Okay, thanks for clearing that up.
Okay, shall we get started? I think we've got about 25 participants so far, and I make it 9 a.m. Central Time. So welcome to the live workshop, everybody. This is one of several PL meets UX events at Splash this year. So there's Hatra tomorrow and there's Plateau on Thursday. So the emphasis on live, I guess, is a little bit more on new kinds of interactive tools for making programming easier. And we've been running for quite a few years now. So just some kind of sort of administrative stuff. So the Clowder break room, I think we should probably reserve that just for any kind of administrative questions. If anyone wants to ask something, post it there. We'll get back to you in one of the breaks. It's going to be a GatherTown virtual pub afterwards. So there'll be a kind of 40-minute break at the end of the workshop, and then we'll reconvene at, I think it's 3 p.m. Central Time or 10 p.m. GMT, and we'll just have a bit of a social in the VUB. During the talks, I think it's nice if people keep their video on, so the speakers can get a bit of kind of visual feedback. But if you keep your audio muted, feel free to post questions in the chat, and at the end we'll take some questions from the chat, and we'll also invite people to unmute themselves and join in via Zoom, and just use your raised hand option in Zoom to do that. So the format's going to be, we've got a keynote, and then I have a couple of short talks. Then we've got 2 sessions after the break. Both of the sessions are longer talks, and the short talks are going to be 6 minutes plus 4 minutes of questions, and the longer talks will be 12 minutes plus 8 minutes of questions. Any questions, anyone? Oh, something in the chat. Okay, yeah. Jun's just reminded me that there is a spreadsheet to just put your name in, because we're supposed to keep track of attendees. So if you could do that, please. There's a link in the chat. Okay, so let me introduce our keynote speaker. So our keynote today is Mary Beth Carey. She's just finished her PhD in the Human Computer Interaction Institute at CMU. And she's basically interested in programming practices and improving developer experience. And she's especially interested in data science and exploratory data analysis, and using methods from HCI to kind of make that easier and design new tools. And she's also passionate about HCI, ethical considerations surrounding HCI and design. And most recently, she's worked on a really interesting system called Mage, which is a system for notebook programming, which supports tools that can represent themselves as both code and GUI widgets. So hopefully that's something we're going to hear a bit about today. And I think she's also currently available for a postdoc. So that's something you might like to talk to her about afterwards. And over to you, Mary Beth.
Cool, thanks. Thank you so much for inviting me. Still a mystery why you did, but I'm very excited to talk about anything to do with live programming. And I love talking about notebook programming, which is what I'm going to share a bit about today. I'm going to cover sort of a big picture around notebook programming, and then more specifically our recent Mage work, which really already introduced. All right, so quick speaker stats. I'm actually a current PhD student. I am still in the dredge of finishing my thesis. I work at Carnegie Mellon University in the Human Computer Interaction Institute. My advisor is Brad Myers, and we work on everything to do with programming in HCI sort of lens. I particularly love exploratory creative forms of programming. My background is in art, actually, before I kind of found the light of computer science. So I love programming as a kind of creative medium, and I spent a really lot of time lately thinking about how people explore, particularly with data, in the context of programming and notebook programming. So I'm going to talk a whole lot about notebook programming, and I'm first going to introduce it just in case you're not familiar. It's a massively popular form of interactive computing and programming, has become really, really hot in the past, say, 10 years, 20 years at best, mostly past 10 years. So this is really popular, it's really new, sort of. And this is approximately what it looks like. So this is the canonical notebook programming interface. This is a Jupyter notebook. It runs in a browser. So this is my little Chrome tab. I've got all of these cells that I can run, and it's an interactive programming session. So to break this down a little further, I want to kind of cover, these are the key components of a notebook programming interface. And they can take lots of forms, but these are sort of the constants across all notebook programming. You've got a bunch of cells. Each of these cells can be one of three, let's say, things. The first is formatted text, so Markdown usually. You can have headers and rich text, little symbols, equations, pictures, videos, whatever you like. And this is really for explaining your code, usually an analysis of data. Then you've got these code cells. Code cells can be run one at a time. They can just change state, like this import statement, or they can have output. Output can be visual, it can be interactive, it can be multimedia, or it can just be plain text that you'd see in like a terminal output type thing. So a notebook has all these cells, they're run one at a time, and it's run in a context of an interactive programming session. So when you run one of these, it updates the state of the whole programming session, and this is sustained throughout your programming session. All right, so I believe that notebooks are really, really awesome, and I hope to convince you of that too. However, notebook programming is a more recent sort of programming paradigm, and it definitely does have limitations. It's not awesome for everything, and I'll be the first to admit that. So if you want to learn more about the drawbacks of notebook programming, I'm not going to go into it, but I can point you to some great places. The first, in 2018, Joel Gruss gave this talk at JupyterCon on I don't like notebooks. And that's such a power move to diss notebooks at a conference about notebooks. But it's a really funny talk. It's on YouTube, and it goes into a lot of details. a lot of the complaints have to do with notebooks are not really that great as software artifacts. They have a lot of flaws. If you're doing software engineering with notebooks, just stop, don't do it. That's a lot of what's going on in that. And then in 2020, this awesome team of programming HCI-ish researchers came out with this paper at CHI on what is wrong with computational notebooks. And they did a study of a bunch of people and list out a bunch of stuff. It's a lot of the same kind of things. Notebook programming is not necessarily a great software artifact. It has a lot of problems with scalability and correctness and all the things we love as computer scientists. However, I like to center all conversations around notebooks around what are their primary use cases. So yeah, they're not for everything, but what are they really, really good at? Now, these are 3 use cases that we kind of came up with. We went to JupyterCon, the same conference that Joel talked at, and we basically interviewed a whole bunch of users of notebooks and said, well, what do you use notebooks for? And we did the whole HCI process of getting all that data together, boiled it down. These are 3 sort of main use cases that notebooks excel at and lots of people use it for. So the first one is a scratch pad. So the kind of thing that you would jot down on a napkin or a back of an envelope or something. People use notebooks to try out quick ideas, just like they use that interactive programming session to just like get syntax right, or try out a risky idea that they don't want to put in their like real important code. The second one is prolonged experimentation. So this is really popular if you're doing data analysis, you're building up an analysis, you're building up a model or whatever. You're going to spend a lot of time sort of showing your work, showing your progress, and showing your process in a notebook. A lot of people like to think it's sort of a substitute for sort of the pen and paper style of a lab notebook that you would have if you were, a chemist. If you're a computational chemist, maybe the notebook programming environment is your lab notebook. And the last one that's really important is notebooks as presentation. A lot of people use notebooks to actually share data analysis or models with other people. And this happens in education settings, like for teaching purposes or for presentations at companies, for like conveying information to people. So these use cases are really popular for what notebooks do, but they also are pretty distinct in what maybe would best serve those use cases. Now, in this, just to give you the quick scope of this talk, I'm going to be introducing a lot of ideas about notebooks. And what I really, really want to convince you of is 2 things. The first, notebook programming is not really established. It's been around for a while, but it's still actively evolving as a real notebook programming kind of paradigm. Like what it means is very negotiable still. People have a lot of opinions. And you as researchers and as like people who develop tools can have a lot of impact on what notebook programming is. So that's fun. And the second part is really more focused around live programming. And that is that liveliness, reactivity, and interactivity are really, really important to what we're doing next in terms of notebook programming. And I'm going to share some of my research in that space. So to start with the first one, I want to kind of convince you what notebook programming is and that it's a very hazy thing currently. And to do that, I'd like to actually take us on a brief history story time. I love history story times. I love history of computing. And notebooks have a really kind of interesting origin story. So they actually date from 1988 is the first sort of public record of a notebook that I can find. And despite that, they're really only evolving as a popular programming paradigm now. So what I found, this is my own interpretation of history, let's say, from reading a bunch of work on notebooks, is that these sort of 3 use cases that we found, presentation, experimentation, and scratch pads, actually are a kind of combination of ideas from 3-ish sort of historical traditions of programming. And the really fun thing is none of these traditions of programming are actually mainstream software engineering. So that's pretty fun. So I'm going to walk us through a little bit of history. I wasn't alive then when a lot of this stuff happened. So if you were, please feel free to correct me. All right. So the first spot I want to hit is 1984. We see the introduction of literate programming. Now, literate programming and notebooks together are talked about a lot in the past 5 years or so. So we see a lot of stuff like this. Literate programming we talk about in the terms of these markdown cells that we see in our notebooks, the markdown cells that allow us to explain what's going on. And literate programming is talked about a lot in the situation of presentation. So here's a snippet from Hacker News, somebody saying, Jupyter Notebooks seem to be the modern form of literate programming because look, I'm seeing people write entire textbooks in this sort of literate style in this programming environment. So people do write entire programming textbooks in notebooks. That's a thing. And so a lot of people have tied it to the idea of literate programming. And in 2018, we see the study where researchers went and looked at like all the notebooks they could find on the internet, pretty much, GitHub everywhere. And they were like, oh my gosh, people are not like actually putting Markdown in these rich explanations in their notebook. And oh my goodness, I really think they should. That's pretty much what the researchers coming up with. However, what I really think is fun about this is although we have this pretty strong idea, if you dig into the community today, that, oh gosh, notebooks are literate programming environments, this is really sort of something that we added very recently. And literate programming in 1984 was not about notebooks at all. It's really not even that related. But what happened in 1984, Donald Knuth introduces literate programming. He's best known for creating TeX, which is the predecessor of LaTeX, which many of us use. And his big idea is that documentation should be equally important to the code itself. So you're writing code, you should also write a ton of documentation, and that documentation should be treated as a first-class citizen by being rich text, side-by-side interleaved with code. And that idea has really resonated to what we do today. But what we think of as literate programming today is this whole markdown business in our notebooks. That's really, really not what they were actually talking about in 1984. In 1984, literate programming was actually a campaign in the idea of we have really bad software documentation and we need good software documentation. So software documentation for software engineering was bad in the 1980s. It's bad now. I don't have time to sort of go into that rich literature, but I'm just going to sum it up in these memes, which is basically documentation takes a really long time to make. It's never up to date and nobody wants to do it. So Donald Knuth is like, oh my gosh, we should make documentation like the be all end all of what we do. And we should make code super, super readable by adding more documentation. And the central irony, I think, of this 1984 paper is that this notation here is what he actually meant by literate programming. And to me, this is not remotely readable. I would not want to write in this ever. And this doesn't even look like plain English, but at the time, that's what he was going for. Just as a side note, I think these old papers are super funny because people say like way more spicy stuff than they do today. So in this particular instance, he says pretty much, if you're a real computer scientist, you're gonna like my notation. And if you're not a real computer scientist or you don't care about documentation, you won't. So that definitely makes me a not real computer scientist. Anyway, literate programming comes into fashion, goes out of fashion really quickly because it actually doesn't solve any of these major problems. Adding more documentation doesn't solve the problem of it going out of date, no one wants to write it, and it takes forever. So it doesn't get adopted here, but it does have an important impact, these two ideas, in the future on what we think about in notebook programming. Now in 1988, we have our first notebook appear, and this is the first one that I can find, at least. So there may have been others previous, but this is definitely the first public release of a notebook. And it occurs in Mathematica. It's designed by Theodore Gray for Mathematica. That's a software suite for mathematicians. It's based on computational algebra languages. And what I really want you to take away here is this is 1988 notebook. This is a 2015 notebook. They're basically the same in terms of the layout. You have these little cells of code. You have your visual output. It's the same deal. Basically, the whole layout and design of a notebook really did not evolve from 1988 until 2015 or so. Same thing. All right, the big sort of turning point where we start to get into modern data computing, modern understanding of notebook computing is around 2001. So in 2001, IPython is released. IPython is created by Fernando Perez. Later, Brian Granger joins the project. And they are both physicists, and they want to create better software and do better coding. And they're like, everybody stop programming in Fortran. We are going to make Python the place where you want to do your scientific computing. So they make this really nice interactive shell. It's like you type in your terminal, it's an interactive shell programming environment, and allows you to create these nice visualizations that are interactive and try out stuff. So a key point I want to point out from both of these things at this point is that our notebook in Mathematica and our IPython shell are both forms of interactive programming. These are not your standard software artifact. This is a quick, I'm going to try a bunch of stuff out and see what happens form of programming, specifically for scientists and mathematicians. That's because science, math, and data really needs interactive programming to work with. Why? It's because most of what you're doing when you're engaging with science, math, and data through computation is doing exploratory programming. And what that means is we delve into a paper like way back in 2017. It has origins in the 80s, just like everything else. But the general idea of exploratory programming is that you're going into a code not knowing exactly what you're going to find. You're using code to explore ideas and experiment, try stuff out. And it's not like when you're given, an image of a black hole, you can like, oh, I'll just write the code that gives the image of the black hole. No, you have to try stuff out before you're sort of able to produce that. There's not a nice program specification or plan that you can implement like you can in software engineering, perhaps. So in 2011, we finally get what we know as the modern notebook. And that comes out of a combination of these three sort of strains of ideas. Now, IPython was originally sort of a scratchpad environment. It's a terminal. It was completely transient. You couldn't keep your code unless you copy pasted it into like an editor. So what they decide is they really want you to be able to do everything you can exploratory in IPython, but do it in a way that can be kept, shared, and reproduced. And they basically copy the design of tools like Mathematica because, again, Brian Granger and Fernando Perez are physicists. That's the style of notebook programming they are very familiar with as scientists. So they copy this sort of design. They bring in the IPython sort of interactive computing in Python. And they also, at this point, loop in literate programming. And the purpose of that is that they want to be able to explain what's going on in this computation. Weird. So here with symbols and stuff, because science code in itself is not self-explanatory. You sort of have to give people context for what you're doing. So all these ideas are combined into a notebook. In 2011, this is sort of our canonical notebook that we understand, but a really fun kind of trivia bit is that they actually took 10 years to develop this notebook. So if you ever feel slow about creating your software, you're in good company. And they actually say that because it took them 10 years to release this notebook, they were able to see a lot of preliminary earlier forms of notebooks that people were coming out with. They weren't the only people who had this idea. And they were able to take what they didn't like about it and create IPython notebooks, which were really a combination of the best ideas of things. And it really takes off. So they have 2 million users by 2015. That's just 4 short years. And what's happening around this time, why notebooks sort of explode into popularity, is that previously notebooks were really this niche thing for mathematicians, scientists. All of a sudden in the 2010s, everybody's got like oodles of data. Everybody needs to work with data. Suddenly, everybody is doing scientific data computing, mathematical computing. Everybody needs to do it. So this becomes from a niche thing just for scientists to something that everybody wants. And notebooks are a nice way to compromise that interactive programming environment with something that you can share, reproduce, so on. So in 2014, 2015, although IPython notebooks were originally just like a little feature in IPython sort of suite, it branches off into its own project because it's become so successful that it actually eclipses the original project for IPython. So they transitioned to Project Jupyter to make something language agnostic, although I think that's actually pretty funny because they want to make a language agnostic notebook, but then they name it after their 3 favorite programming languages. They take Julia, Python, and R and just like smush them together into Jupyter, and that's Jupyter. So around this time, we have Jupyter release. Notebooks become sort of a formalized thing available to everybody. And what I really like reading from this time is that Perez and Granger, are trying to transition into Jupyter notebooks. They need money. Everybody needs money to get your work done. They're a free open source project. They need funding. So they write this grant in 2015, which you can read. It's online, and they kind of project what are our main goals for notebooks in the next 5-10 years. And although this is really interesting as like a tidbit of open source software history, I think the goals they lay out actually are pretty much what all of us have been working on in notebooks for the last 10 years or so. Or it hasn't been 10 years, whatever. Up until now, this is something that the whole community has been working on. All right, so the first one is a focus on computational narrative to support reproducibility and comprehension. So the notebook interface was originally just sort of like an interactive terminal thing. It was just sort of like a, we're trying out some code. We're pivoting to making notebooks more about storytelling, more about narrative to support all those people who are actually adopting notebooks as a way to educate and share with others. So that's a really big goal. The second part is we want to make computational narratives more accessible to a non-coding audience. And you may be like, hold up, wait, what? We're talking about Python, we're talking about a programming environment. But remember, a lot of the original users for notebooks were scientists or mathematicians. They're not coding experts. They may be experts in chemistry or astronomy. So making computational narrative something that not a coding expert can access and work with is really, really important for their core users. So they propose making computational narratives more accessible to a non-coding audience by allowing non-coders in the notebook to do statistical analysis and visualizations on data from new samples using a simplified graphical user interface. So basically what they're saying is that we want notebooks not only to just be like this coding platform, we also want people to be able to do work through GUIs and widgets in this environment to do data analysis work even if they can't code. So that's pretty important. That's something we haven't really achieved. And the third one is collaboration. This one I'm not going to go into. It should be pretty self-explanatory. In science, we need collaboration. In data analysis, we need collaboration. In teaching settings, team settings. So this has been a focus of a lot of notebook work. All right, so by 2014, 2015, all of a sudden, notebooks are much bigger. They kind of explode out, and notebook programming is much bigger than the canonical IPython notebook. It's become something that lots and lots of companies, important tech companies, all sorts of startups and different players are kind of taking their own approach to. So since 2015, we've seen a lot of notebook programming platforms and different languages sort of like pop out of nowhere. And here are 10 of the most common that I could think of, but there are a lot more. And many of these are really pretty much clones of the classic Jupyter notebook we've been looking at, but each of them take what notebook programming is in their own sort of flavor and direction. So at this point, I really want to sort of highlight two types of notebook that we find in 2020 that are taking notebook programming in pretty different directions. And I want to highlight these two examples, not because they're like the best notebook platforms ever, but because they're really, really different. And I want to sort of convince you that notebook programming is something that you can take wherever you want. And it's something that is happening right now. And as a tool builder and as a researcher, you can have a lot of say in that. So on the left, this is Observable. It's created in 2018. And on the right is JupyterLab, which is from 2019-ish. So JupyterLab is the second generation of Jupyter notebooks from the original IPython Jupyter team. And what you can see is they've translated a notebook into something that looks a lot more like your everyday IDE. If we look over here on Observable, this is also a notebook. However, it doesn't look like an IDE. There's a lot of visuals. There's like this pretty stuff going on with text, and there's barely any code to be found. So I'm going to contrast these two examples. I would say JupyterLab represents a kind of bigger agenda in the notebook community, which I would call software engineering needs to come save us. Basically, we want notebooks to translate into something that's more of a respectable, legit software artifact. And this comes out of all of a sudden notebooks are being used by everyone. Everybody needs to use it. And all of a sudden, software engineers have to deal with notebooks that were created by academics and researchers and those flaky hooligans that are making this exploratory, messy code. So from a software engineering lens, it's sort of this a little bit preaching of we're going to convert these wild exploratory programmers into creating good code and creating code that can be actually translated into production systems. So this comes out of the frustration of software engineers who have to work with data analysis and data scientists and visualization people. They want software engineering to sort of be integrated into notebook programming, make it that unruly messiness something a little more easy to deal with. And we can see this in JupyterLab. They're kind of translating notebooks into a traditional IDE environment. Most IDEs today, like Visual Studio Code, as of like 2019, 2020, are integrating in notebook viewers in the classic IDE. So you can use your, linters or formatters or what have you, nice software tools to make all of your notebook code super awesome. And we also have in the research community, this is a Kai paper from 2019, in which a bunch of really cool people at Microsoft, UC Berkeley, Georgia Tech, et cetera, are trying to see how we can sort of refactor notebooks for people, make them nice. So this is something I very much believe in, but there is a tension. I went to a Jupyter conference a couple times to talk with users to sort of get their feel about notebook programming, what they want. And as somebody who's been trained in software engineering, I'm like, of course you want to see the light and like become a good software engineer. But if you think about who are the original core users of notebooks, these are scientists, researchers, people that aren't software engineers and they don't really want to be software engineers. So there is a little bit of resentment among some parts of the community who think that this direction is actually trying to force everybody to be a software engineer when they don't want to be. So I'm presenting the tension there, but I do believe in this mission. A second major agenda that is more on the side of the other notebook I was showing you, the observable ones, is that instead of pushing notebooks in a software engineering direction, we want to push it more in an end user programming direction and more of a non-programming direction, honestly. So we want interactive visual exploration through widgets to let everybody understand data, even if you're not able to code. So the problem is data computation already is intensive for visualization and explanation. And code is really, really abstract when you get to data and stuff. So even if you're an expert, you do a lot of visualizations, and especially if you're not an expert and not a coder, interactions and visualization can give you a lot of information. So I'm going to show you a brief example in Observable. This is a notebook where you're going to see almost no code. So this is maybe a little bit of a traumatizing visualization for us in the US recently, at least. This visualization allows you to sort of play with different options for who would win the election under which circumstances. And this is an interactive visualization. Now we see a lot of text in this notebook explaining the visualization. And at the bottom, we see a whole bunch of code, which is how we made the visualization. So this notebook really has at its center the interactive visualization for some kind of audience who's going to look at this notebook and isn't maybe interested in the code. All right. And at this point in the talk, I want to pivot away from looking at notebooks globally to really focusing in on this idea of live interactivity and this idea around widgets. So what we saw in this example just now in observables is a really common style of notebooks today where we're using notebooks to create sort of a dashboard or interactive widgets to show our students, show our audience, show somebody who's not coding to be able to explore data and understand stuff. And this is really, really common, not just in observables, but any notebook platform. The second widget style, which now I want to kind of pivot to talking about, is a little bit different. We're going to use widgets to do sort of live programming to actually help us explore ideas in the process of coding. So it's not that we're coding to produce a widget for someone else, but rather we're using the widget to help us in our own process. And the line there is a little fuzzy, but again, I'm going to show you observable just because it's really pretty. And what you can see here, let me pause. I think it's going a little fast. There's a slider here. Oh, what? I'm sorry. I clicked too many things. There is a slider here. There is a value of X here. It's a little bit blocked by the Zoom thing. Basically what happens is, Zoom, go away. When you move the slider in the notebook, it changes the value of X. And this is doing something that's called reactive programming. So if I create a value Y that adds 10 to X, that's a value. And then I go back with my slider to play around with X. This is not only going to update the value of X, it's also going to update the value of Y. This is called reactive programming because what it's doing is keeping track of the dependencies on X so that that little slider is going to update the entire state in my notebook appropriately. So reactivity is an important part of interaction in the notebook. Not all notebooks support it. It's kind of an opinion thing. So I just wanted to put that out there. Now, most of widgets in notebooks today look a lot like this. They're sliders. Observables has a lot of pretty sliders. We have things like sliders, color pickers, iPie widgets in your standard notebook. You can do drop-down menus or click on a value or something like that. But ultimately, all we have in mainstream notebooks, pretty much, no matter how pretty this is we're adjusting our code through basic parameter tuning. We can change a single value like color, rotation, quake size through tuning a parameter, but we can't really do like rich analysis work beyond I'm going to play with this parameter. That's sort of all we got. And if we return back to these ideas that Perez and Granger put out in 2015, they want to make computational narratives accessible to non-coding so that you can, if you're a non-coder, you can do actual meaningful, real data analysis using these GUI widget tools. But at this point, all we have is parameter tuning. So the idea is, can we do more than that? And this is the topic of my latest research, which I did with some collaborators at Apple. So this I presented at WIS 2020 is pretty fun. So I definitely hope you will check it out. And what Mage is about is trying to move in a general sense beyond that like widget thing of just parameter tuning. So I'm going to show a quick demo video so you get a sense. This is a notebook. In the notebook, I'm going to load a data set of Pokemon because I love Pokemon. And I'm going to sort of demonstrate what interactivity looks like now and what we want it to be. So here I'm going to show a table. This is what you see in a notebook today, and you can like see it, but you can't really like do anything with it. So what we want to do in Mage instead should be pretty obvious, and we're definitely not the first to propose this, but we want to create a table where you can actually do stuff like you could in like Numbers or Excel. So in this Pokemon table, I'm going to actually be able to drag around columns, for example. And when I move the name of the Pokemon to the front of the table, this is actually going to generate code that achieves that action. And I can go on and keep organizing my table, and that's going to generate code that appropriately matches what I'm doing. Now, at this point, you may be like, wait, why do we need to generate code? Why can't we just like play around in a table all day? And that's a little bit of a contentious issue, but basically, there are some widgets that allow you to play around on a table all day, but they break reproducibility and they're very, very fragile. So if your internet goes out or your session needs to restart or something, you may lose all of your work in this table. By translating it into code, we ensure that everything you do is reproducible and that you're not going to lose any of that work. So seeing code maybe isn't for everybody, but it is a really important medium to allow reproducibility, readability of like, oh, this is what the actions that you did, this is how you transform the table, and allow you to keep your work in a meaningful way. All right, now I'm going to show you a second example. In this one, instead of playing around with tables, we're going to play around with plots. So I hope I did not mess this up. I think I messed this up. I messed this up. Let me see if this is the right video. Okay, now I'm not messed up anymore. So this time we're going to summon a plot tool instead of a table tool. And this is an interactive chart builder. So I can build a chart in Python, you can build a chart in Python, but it takes, it's really fussy. Like you can grab code, but it's really, really fussy. So what we're going to do instead is use this sort of GUI-based chart builder to create some visualizations of our Pokemon. And the magical thing we could do is we can actually select from the GUI and take it back into code. And then we can also use our table tool to do some more like data analysis, this time on just the selection of our psychic Pokemon. So what I'm trying to show here is that we can actually achieve this fluid back and forth between working in code and working in GUI. We don't really need to choose between the two like we have to today in a lot of tools. All right, so the main point is that we can have rich GUI tools that allow us to do rich kinds of data work that's actually affecting the state, actually affecting your data in a notebook. And how we're going to bridge the gap between these rich GUI tools and notebook computing is that we're going to generate code for you. And what we did in this paper is we tried out a whole bunch of different GUI widget type things because our goal was to see, can we figure out something that will generalize, that we can bring to tool creators that they can create their widget and create something that can generate code, because generating code is kind of hard. So what we do in this case is we try to use the simplest solution possible. We use code templates. So what this looks like is you have your table. This is a table. You can do a lot of table-y things to it, right? And what we have is we have the tool creator, the person who creates this nice little table widget. In this case, it was me. Also come up with templates. And whoops, this is what they look like. So we can have multiple code templates to allow the same GUI tool to support all kinds of different languages, all kinds of different platforms. What it looks like, if you're not familiar with code templates, is basically we've got a type-based fill in the blank. They're going to say, okay, we need a data frame, we need columns, and this is for removing columns, produce code that looks something like this. Insert their table, and this is the actual syntax that we need to create, and drop the specific columns that they select in the GUI. So the GUI tool creator is giving us a template, and they're giving us in live real time what is actually happening, so that Mage is going to take this template and resolve it based on the actual programming environment. So the tool creator doesn't need to know all the static analysis stuff about what's going on in the programming environment. They just sort of give us instructions about what should happen, and Mage sort of makes that happen. And what this looks like is pretty good sometimes, but there's a major limitation to our approach, which we don't solve. And that is nice code generation that looks fluid and looks good and is readable is actually really context dependent. So simply, outputting some new generated code every time somebody does something in the table creates a complete mess. So here's a very simple example. In this example, I add a column called education into my table, and then I move that column from 14 to 2. So I'm just inserting a column and then I'm moving it. Now, what we'd like is, instead of inserting it and moving it, we could, if I was a human generating this code, I'd probably just write, okay, I'm just going to insert it at 2 in the first place. This is much nicer code. It's 2 lines instead of 5 or 6 to do the same thing. So what we can do in Mage is kind of create these combined compressed forms of code that actually look nice and readable, but it requires context dependent information from the tool creator, because we don't know how operations combine. We don't know the order of operations for a table versus an image editor or all these other possible forms of tools. So this is a major problem because it puts a lot more spec requirements and all that sort of nonsense on the tool creator. So the main idea I want you to take from Mage is that this kind of powerful sort of tools for working in GUIs and code are really possible, but the generalization bit is what's really hard. And I want to highlight some related work that does really similar things recently, and that's Rex is a table editor. It's using Program by Example, which many of us are familiar with. Basically, we have somebody working in the table and it generates code for them based on example. B2 is another really recent one. It allows people to play around with visualizations, and it's going to generate code to generate those visualizations in live, real time, in a reactive way based on their selections. Now, the power in these two is that they're not trying to generalize. B2 uses a domain-specific language, a DSL, to power this, and Rex uses programming by example that only works for tables. So these two things can be super powerful DSLs and programming by example in one tool in a specific context, but it's hard to generalize. So this is an open challenge I just want to sort of leave you with, is that live programming via GUIs, it allows more people to participate in data analysis. It really is a goal of the community, but it's really hard to generalize between the simple parameter tuning that we have today to something that is substantially more powerful. And as I wrap up, I also want to sort of push again that notebook programming means a lot of different things to different people. Use cases are pretty far across the board in a lot of different people, and communities are pushing notebook programming in different ways. And as a tool developer and as a researcher, you have a lot of power if you want to get involved in notebook programming to set the agenda for what that is. All right. And yes, again, just to sort of conclude here, I hope that you get involved in notebook programming as live programming researchers. There's a lot to do in that space if you're interested in interactivity, and you can have a lot of influence on that space. So thank you so much for hearing all about notebooks, and I'm happy to take questions.
Okay, fantastic. Thank you, Mary Beth. That was a really, really great talk. Okay, so we've ended with 15 minutes, which is what perfect timing. So feel free to either put a question into chat if you want me to ask it, or if you want to just unmute yourself and ask it yourself. That's probably a nicer way to do it. So feel free to do that as well. And by the way, we had 50 participants for that, so that was pretty cool. Very good attendance.
Cool.
So we've got Ravi, I think.
Thanks for the great talk, Mary Beth. That was really interesting. So I wanted to ask about how in Mage you're kind of, is it Mage or Mage? Or both, okay. How you're able to kind of like, say that you don't have to choose either code or GUI, you can kind of, bridge the gap. I also wonder if that same goal could apply to these two splits that you showed between Jupyter Lab as like a software engineering IDE kind of thing versus something more end user or non-programmer focused. I wonder if you think that dichotomy is something that could also be bridged. Does it really have to be that these tools either have to be built for like production software engineering or for everybody else, or can that be kind of bridged as well, do you think?
I think that's a bit tricky, actually, because that gap between I'm a pro software engineer coder and the more end user programming side is really, really pervasive. So when we actually, sorry, slides. Okay, so we took a lot of these tools to professional data scientists. I didn't talk about that, but we set it in front of people who do this for a living. Some of them are, end user program side, they're statisticians or something, and others are software engineers. And what we found is a really big divide on some people loved this especially if they didn't like writing code and they liked working in like a spreadsheet or something that was more familiar. But a lot of people who were coding experts was like, I would never use this because I just want to code all day. So I think it's really hard to kind of meet requirements of everyone, if that answers your question.
Rabbi, you're muted, I think, if you were replying there.
Oh, sorry. Yeah, I think, yeah, I said that does answer my question. Yeah, I think it is hard. I guess I wonder how many humans are in like this intersection where they might want to do both, but you're right. Satisfying all of these goals is certainly a huge challenge.
Yeah, I do want to add that a lot of the visualization and widget oriented work is, a lot of it is for end user programmers, but a lot of it is also for professional programmers. Even if you're a machine learning developer expert, for example, those people really, really, really want interactive widgets for their super complex tasks because it's cognitively like even too difficult for them. So it's not, everybody does need widgets and interaction. It's just sort of a matter of what and when.
So I have a question. If nobody else does, please feel free to put your hand up if you do. It's got a slight variation, I suppose, on Rabbi's question, which is, I guess you touched on this when you were talking about the different use cases, like kind of exploratory data analysis versus presentation, for example. So you could imagine, even as a single person with a particular kind of skill set, you might still have a reason for your notebook to have different audiences at different times. You know, so it seems kind of a bit of a drag in a way to ask people to take their work and write it up in a really nice sort of presented way and a really kind of explanatory way for one audience, and then use a completely different notebook for doing the actual work. Have you thought about how you could kind of have different views of the same document that kind of serve the needs of different stakeholders, if you like? You know, you could imagine taking a piece of work and giving it to a funder, writing it up one way, writing something up for a kind of public, you know, a sort of popular science audience, and something for perhaps teaching, and sort of derive all those from the same underlying computational data science.
Yeah, that is super, super interesting. So there's a couple things here. The sort of three use cases, oftentimes it's very common for somebody to transition between. So like you said, like I'm working on something, but now I need to write it up for somebody, and I'm going to add a bunch of explanation. And then you end up with a very different notebook and a very different set of stuff than what you want to work on. And sort of maintaining state between those two can be really tricky. Sort of my 9-to-5 job, so to speak, in my dissertation, I'm really interested in sort of version control, sort of geared solutions of how to sort of get back to where you're interested in and not sort of have to make that compromise. But I think it's a really interesting open problem. And I think a lot of people are interested in ways of presenting the same notebook to different audiences. Sorry, it's a little long-winded, but one thing users said when I interviewed is that some people really never want to see the code. If you're a manager, you don't want to see the code, but other members of the team do want to see the code because they want to give you code reviews. So the same document is going to convey different information for different people, and not everybody wants to see the same information. So that's a really important point.
Yeah, and as you say, the challenge you run into, I guess, is when one view gets kind of stale because you're focusing on another view, and then you need to sort of reconcile things, or you just risk kind of invalidating work you've done for a different audience.
Yeah, I think it could be a really rad tool to facilitate that. Somebody needs to do that.
Okay, we've got a couple of questions from the audience now. So Jens, first of all.
Okay, thank you for the excellent presentation. In Mage, I wonder, you motivated mixing the UI and sorting table and inserting things and focusing things and produce code and produce Python or other code. Did you think about at the pre-step of it, maybe just show the user the configuration, like this table is sorted, this column is moved, like in a JSON file or some other thing? Like when you have a configuration, you might not have to go the full way of being a full programming language, and it might be easier to generate.
Yeah, so that's a really interesting bit. So we do have one example that we explored, actually because we ran out of time. In visualization, we used a Vega Lite specification language, which is much more similar to something that you can pop in a JSON file and read. And it's meant to be easier to edit than writing Python to do visualization. We wanted to support Python, but we ran out of time, so we just plopped in this spec language. Is what happened. And I think, like you say, this is easier for some people and some people hate it. It's really kind of a matter of opinion. So some people
At least
like
it
the
would
spec
be
language.
easier for you to support and to implement. Not maybe easier to use, but eventually maybe it's like you motivated it with, okay, we want to make it reproducible and things. And then I said, oh, but then you went all the way, and now we have programming by example we have to do. So, but okay.
Yeah, so in the short term, just generating a spec that can reproduce the state of what they ended up with, that is a really good idea. For you avoid a lot of the complexity of actual code generation by just kind of keeping this spec. This example is way simpler than all of our other examples because we can just use the spec. It's not as, the thing you lose there is you, for the people who are sort of in between, they do want to work with both code and GUI, you do lose usability there because people generally want to work in something more portable, and you do have to kind of create your own spec for every GUI. But as a short-term solution to sort of save state and allow people to work in GUI, this does definitely work.
Thank you very much.
Okay, I'm going to take one more question from the audience and then take a question from the chat. So Raphael, first of all.
Hi, thank you. Raphael Wimmer, University of Regensburg. A notebook is some kind of a framework where you have a strict order, where you have dependencies between parts, and that's very helpful in many cases. But is there any research, are there any notebooks which are more like libraries, which allow you to reassemble or combine multiple notebooks? Because at the moment, it's a monolithic notebook. I'm only using one notebook at a time usually. Is there some way to remix notebooks?
So I think that's something that the community is really interested in. So the plain notebook, you can import like Python modules. When people want to use a notebook in a different notebook, oftentimes what they do is export your notebook as a Python module and then import into the next notebook, which is really clunky. So there are definitely projects where people want to import notebooks into other notebooks and make sort of these meta notebooks. I think some people who are critics of that approach think that it might just be a rabbit hole of notebooks, of this maze of crazy notebook code that's not like a nice formal like Python or R module. But yeah, they're really, so you can move around cells in notebooks, and in the classic notebook, you can actually run them in any order. So the dependency thing is really more of a recent push. They're really more free and wild in the original iteration, but you're right in that modularity of bigger pieces is a really big question of how we should do that. And I don't think anybody has an answer. Does that answer your question? I see some frowning.
Thank you.
Raphael, you're muted if you did say anything.
Yes, I'm happy. Thank you.
Okay. Right. So we've got a question from Jeremy in the chat, which is your narrative of notebook origins a revisionist history? Asked in a friendly way, does interactive computational notebook programming spring from a tradition of read-eval print loops going all the way back to Lisp?
It definitely comes from Lisp. Yeah, I sort of, it is a little bit of a revisionist history. I sort of picked and choose some spots that I thought were particularly important, but yeah, we're going all the way back to Lisp for real, especially in the interactive computing in a terminal that goes way back to the very beginning of computing. What I really want to show here in particular is that from what I can find currently of where notebooks come from, almost all of them are revisionist histories. They're really contradictory. So some people think that notebooks sort of sprang out of literate programming. That's definitely false. And I'm trying to just say they come from a bunch of different places. But if you actually know more about what they came from. That would be really interesting, because I don't think anybody really knows, other than it seems to have come about of people encountered something they liked and they added it together into a tool, and then someone else encountered something else and then they added it. But there's no real formal lineage that I can find of these things, if that makes sense. So yeah, it's totally made up.
I'll just follow up with a kind of finger on that, just because we don't have another question in the queue. But actually, one thing that occurred to me is that, you know, another sort of dimension, if you like, of the history of notebooks is the history of scientific notebooks. Because I mean, the kind of use cases you talked about, the kind of dissemination versus, you know, recording your kind of workflow for your own use, and so on. They really have a history in the tradition of science itself, I think. So I mean, in the 18th century, whenever people first started publishing journals, that was a kind of response to worries about reproducibility and openness, and that there was all this knowledge locked up in labs and in scientists' heads that wasn't being kind of shared into the community. So it's almost like computing has really brought those concerns to the fore again, and we're just kind of recapitulating all that stuff all over again. And I wondered if you thought about that as a kind of parallel narrative in a sense.
Yeah, there's a huge backstory in scientific computing for sort of the computational lab notebook. And there's been, over the decades, like a lot of different sort of attempts to make a computational lab notebook. But the thing is, nobody's really come up with a solution that everyone's happy with. There is no real killer app that people have for a computational, like, scientific lab notebook. A lot of people are hoping that notebooks would be it, and it really hasn't shaped out to be perfect for that either. So that's definitely one origin story, but that gets into all of these like crazy interactive systems I didn't quite want to get into. Yeah.
Okay, we've got one quick question we'll take from the chat. So do you know any work that combines notebooks with inspector-styled environments such as Smalltalk and Self?
I don't know of any. Well, so you mean inspector styles? It's been a while since I've seen Smalltalk.
Well, I can clarify my question. So in Smalltalk, you can point to a piece of code and then say do it or inspect it or print it. And I have the impression that these notebooks, they only are the equivalent of printed. Whereas if you select the menu option, inspect it, an inspector opens up and you can really like dig into the object that you are inspecting. So you can inspect subfields and dig deeper and deeper and deeper, and not just look at whatever has been printed by the regional print loop.
Yeah, so that you can find that not so much in notebook programming, although a lot of people want to combine that in. That's definitely an ask. You can find that in R. R, the programming language, its big IDE is RStudio, and RStudio is an interactive development environment really similar to notebooks. It's not quite the same, but the inspector panel for, like, you click on a line of code, you can either run it or you can inspect like the value of the variables and stuff. I don't think it's as powerful as like what you could do in Smalltalk, but it's the same general idea, and that's a really important feature for R programmers. It's related.
Okay, thank you.
Okay, so let's leave it there. Thank you again, Mary Beth. That was a fantastic talk, and thanks everyone for joining in with questions. Okay, so we're going to move on to the first of our two short talks. So the first one is Hidehiko Masuhara from the Toyota Institute of Technology. And he's going to be talking about a polyglot live programming environment called Poly2Canon. So take it away.
Thanks. I believe my slide is shown to you. Okay, so sorry to have a little bit long title, but what I'm going to talk about is just ongoing talk and trying to make a live programming environment to multiple languages and to multiple programming environment. And what we are going to propose is a framework called PolySquare-Canon. So this is only the name that I want you remember in my talk. Anyway, so let me introduce our previous work called Canon, which was presented in the Onward 2 years ago. Canon is a live programming environment for data structures, where when you type, edit your program here, then the data structures created in this program is automatically visualized on this side, like this way. And we believe this is useful to program that manipulates the data structures. For example, if I want to implement a swap function that swaps the first two datas on the linked list, then we can see what the structure of the data and what this variable is pointing to and what I need to change the fields. And then I can write code, and then immediately I can confirm what my code did. And sometimes I can correct my mistakes, and then confirm my implementation is good enough. So this is the basic idea of the Canon. And so the aim of Canon is to help real programmers. So the education is secondary purposes, but I want to help real programmers who write code or that manipulates data structures. But there are a lot of challenges to deliver Canon to real programmers. And because the current implementation of Canon uses a tiny custom editor running on the web browser, and it's only for JavaScript. But as you know, the real programmers likes to use their own code editors, like VS Code, Eclipse, Vim, sometimes Emacs, and also they want to use their favorite programming languages. That means we need to implement the same features of Canon for many code editors and for many programming languages. And I believe this is also same to you. You guys are developing a very nice live programming environment, and you want to deliver your system to real programmers, then that you would probably need to provide, implement your system to many code editors and in many languages. So, but implementing such a system for many editors and many languages are not easy, because we found two key reasons. One is that we need to, live programming environment, we need to monitor fine-grained editing behavior, like movement of cursors or the changes of the program text. So we tend to develop custom editors. And we also need to extract the information from running program. So like taking a variable or local value of local variable while running in a program. So we tend to Canon. In Canon's case, we implement that by code instrumentation, and some other live programming environment use the custom interpreters or compilers. So that means implementing, so doing the same things for different editors and doing same things for different languages is not trivial, but at least we need to pay a lot of effort to do that. But we also observed that there are a lot of common requirements to editors and programming languages. To editors, we actually need to monitor editing behaviors. Also, as I said, like cursor movement or text changes, and also we also need to show some information inside of the editors, like showing a visualization like Canon, or showing some hints over the text. And for programming language side or runtime of programming language side, we need to monitor program behaviors, like creation of objects or the assignment of field. And then we need to associate that events or behaviors to the positional program text, and also we need to reload or restart the program. So, but those requirements can be set pretty common to many editors and also programming languages.
Hidehiko, we've got a minute or so, so probably try and wrap up.
Okay, so this is just our proposal. So we propose PolySquare Canon, which is a framework. So this is our proposal, and we use the language server protocol, and we try to use the Ground Truffle virtual machine. And I'm going to skip those details, but what we are currently doing is, we are trying to implement the object monitors by modifying GRAL and JS, and we are also examining the LSP language server protocol so that it can be used for the live programming environment. So I'd welcome any advice and suggestion from you. So this is that's it, my talk.
Okay, great. Thank you, Hidehiko. Okay, so we've still got a couple of minutes. We started a minute late, so probably 3 minutes for questions. So fire away.
So this is happening in Growl, is that right? Growl VM?
Will be, yes.
Yeah. Oh, okay. Okay. So coincidentally, I was late for the keynote because of the talk about live coding in Growl VM that was happening in concurrently with this session. So you should definitely check that out. It's interesting stuff.
Okay.
This is a great idea.
Thanks.
So Hidehiko, do you have any thoughts on kind of what kind of infrastructure you could use to do the kind of fine-grained editing tracking in a language agnostic way?
Language agnostic. That's a good point. So at least for Canon, I think we only need to monitor the text level editing behavior, like a cursor movement or the changes of the text. And then the framework part will analyze what is actually happening inside of the other programming language. So I don't need to think about on the editor's side so to me, I think it's sufficient to use the just text level editors, and that's our current analysis, but we will know.
Thanks. Okay, we'll take a question from Ravi, and then that will be the last question, I think.
Thanks, Hidehiko. I'll admit that I don't know as much about language server protocol as I should yet, but I guess I'm curious, does LSP kind of provide enough kind of common concepts and API to build these kind of like very agnostic live programming tools, or does there need to be kind of, a richer API to be able to really achieve that goal?
So we will see. So we haven't finalized our decision, but at least the cursor movement and text edit level, it seems to be quite well fit to the live programming environment. But for displaying the information, we don't know. Maybe for Canon, we need to show the visual information, graphical information, which is not actually covered by LSP, but we can do like a spawn a separate window, then we can also simulate the similar thing. So, and in the end, we might need to extend the LSP protocol partly, but I don't think it's a huge problem, but since LSP is still emerging, so if we can do earlier, then we can also change the LSP itself.
Okay, right, thank you, Hidehiko. That was very interesting. And we'll move on to our last short talk of the morning or afternoon. So our next speaker is Rebecca Krosnick. She's a PhD student at the University of Michigan. She's interested in HCI and in user programming, and today she's going to talk about live feedback in web automation IDEs. Over to you, Rebecca.
Great. Yeah, I'm excited to talk about our in-progress work studying the usability of web automation tools. So web automation is the practice of creating computer programs that automate web tasks. in particular ones that are tedious or frequent. So if you're a manager and you have to approve timesheets for your direct reports every Monday morning, it's going to take some time out of your schedule. And if instead of doing it manually, you actually had a script to programmatically approve all these timesheets, it would save you some time each week. And that's just one example, but there are many others, of course. And so to create a web automation script, people often use a scripting framework like Selenium. So we have a sample script here. And so this script will go to the Google homepage and perform a query. So here, the first line here is actually navigating to the Google homepage. Next, what we need to do is we have the search bar that we need to enter some text into. So first, we actually need to get a reference to that search field. And so to do that, we open the DOM tree, and we, in the bottom right corner, you can see here, this input field in gray corresponds to our search bar on the left. And so we're going to reference this input field using a CSS selector. In this case, we're going to select based on the name attribute whose value equals Q. And so you can see in the code, by.nameQ is how we're going to select the element. And then finally, we type weather and hit enter into this field. And so as you can see, creating a web automation script is largely based on selecting UI elements and interacting with them. So we recently conducted a study where we had users write scripts from scratch, and we observed some challenges that they faced. So one of the biggest challenges was correctly selecting UI elements, in particular, choosing robust CSS selectors. So I'll show you a couple examples of the kinds of challenges people had. So imagine that on the Amazon website, you're trying to select an element from the page. You want to actually select the element that has this bestseller label. So a user might try to select that element based on the element on the page that has this class A badge dash text. But it turns out that classes are not unique. And in particular, this class actually would apply to other elements on the page. For example, this badge of holiday gift guide. So if the user is specifically trying to select the element with the bestseller label, this class is not going to be specific enough. So choosing classes that are unique and specific enough was a challenge that we saw. Another challenge we saw was that IDs are a more unique way of choosing selectors, but it turns out that some websites like Google actually randomly generate their classes and IDs on each page load. So for example, this number 12 would actually be random, would be a different number the next time you load the page. So your script actually wouldn't work the next time you run it. So in order for participants to test their CSS selectors, they either had to run their full script, which is just a slow feedback loop, or some participants had a good strategy of testing individual chunks in their dev console. So here, for example, the participant was checking to see if this class refers to just one element on the page, or if it refers to multiple. And so some future work that we plan to work on is to provide live feedback like this to users on their CSS selectors. For example, showing them error messages of when their selectors are invalid, or warning them that maybe their selector is not unique enough. And there are a number of other challenges that people ran into when they were building their web automation scripts. And in general, we just feel that currently web automation scripting frameworks, it's just code that you're seeing, but rather we think it would be helpful if we provide some UI previews of what the code looks like and what it's doing to the website along the way. So as a first step for this, we have a research prototype where we provide visual context for automation scripts. So in this prototype in particular, the users actually, this is the website that they're on, it's the Southwest website. This prototype actually lets the user record their actions on the web page and generates some initial code based on that trace. And so in addition, it generates a UI animation of the actions that the user took. And then here's the code that's been generated. So let me just zoom in on this part at the bottom for a bit. So here, as you can see, we're seeing an animation of what the code should be doing. And it's showing the user's actions typing into these text fields and clicking buttons. Additionally, if you actually click on lines of code in the script, you can see this orange highlighting is showing the cross-referencing between CSS selectors and the corresponding element in the UI. And additionally, you can see that a given line of code, when you click on it, you can actually see the specific UI. You can see the UI state before and after that line of code. And so this is supposed to help the user really understand what a given line of code does. And so just as a note, currently we're just providing this UI animation for the code that, for static generated code that's been generated from the recording. But we believe this kind of UI preview would really be helpful to provide as a live preview for in-progress code that users are writing. Just in closing, I think it's interesting to point out that web automation is a unique kind of programming. You're interacting with a UI that you don't own. And so there's a lot about it that you might not understand how it works. And also that UI could change at any time. We have no idea what Google or whatever company is gonna do to their website. So I think in general, it's just really, it'd be great if we could provide users more context of what their code is, of whether their code is working and what errors there might be. Thanks.
Okay, great. Thank you, Rebecca. We've got a couple of minutes for questions now, so please either raise your hand or type them into the chat. I think we've got a question from Brian.
No, that's just my clapping.
Okay, sorry, yes, good point.
Jens, though.
Okay, Jens, go ahead.
Yeah, thank you. It's interesting. So you say that Google and others really try to change the IDs and CSS selectors. So do scripts eventually have to go and behave more like a user and say, don't click on this internal idea, but click on the thing that says go or something like this?
Right. Right. So I think strategy that people used in the study was to select by attribute values that were more semantically meaningful. So for example, ARIA labels, or if there was a number, like you could potentially, if this ID was more descriptive, maybe if this is the only input on the page, like I guess you could select by the type input, or you could select by the partial string of the ID, for example. So yeah, it took some people some time to realize that they had to choose stable selectors.
Oh, thank you.
Okay, I've got a quick follow-up actually to that. So I'm not familiar with the kind of web automation literature, but is there any interest in kind of developing a more semantic kind of language for web automation that's more directed around exposing the services of an application rather than its GUI?
Yeah, that's a good point. There's like I guess Sakuli from a few years ago, which is a scripting language that lets you embed images into your language. So you can like say to click on the button that looks like this. So I think that is one approach that kind of lets you provide the more semantic description of what you're trying to interact with. I'm not quite sure what it would probably be interesting for me to explore what the right combination of I guess more of CSS selectors and maybe like computer vision or something could be to select the element that the user intends. So yeah, I think maybe that's something I'll explore, or some other attributes that the user could provide to kind of specify what they want to interact with.
Great. Okay, thank you very much, Rebecca. Okay, so thanks everyone. I think that's the end of our first session. So we had a really good turnout. We've got a 40-minute break now, so we'll keep the Zoom room open for anyone who wants to carry on chatting, and then we'll reconvene at 11 Central Time or 5 p.m. UK GMT. See you all then. Just watching that dwindling collection of faces.
Can I ask a question about the last talk?
Yeah, I'm still here.
Awesome. First of all, thanks for the great talk. As someone who's trying to work on web automation stuff, I found it very insightful into some of the challenges. I was curious if you've thought about workflows where someone concretely selects like examples of the things that they want to select and don't want to select, and then you help them go from those examples to the abstract selector, and if that's been part of your thought process at all?
Yeah. I haven't I haven't made a specific progress on that, but that's something I'd be interested in doing as well. So like maybe a programming by example kind of approach where you could say like, so one of the tasks we had was people have to, we had people select a date from a calendar widget. So if you could maybe have someone provide 2 examples of selecting a date, maybe the script could then maybe the program could then figure out how to generalize that, or like could the user also provide hints, like for example the bestseller label that was orange or something on the page, like if someone could provide a hint that, oh, it's the text that matters, or the text equal the bestseller that matters, or it's the label that's orange that matters. Yeah, that's something that I'd be interested in exploring. But yeah. Are you?
Thanks.
Yeah. Cool.
That makes. I mean, yeah. I just wanted to say I think your idea of like hinting to guide the generalization process is great, and I personally don't think that just automatically going from examples to the abstract selector is going to work too well in this domain. But I think that like your idea of sort of combining those approaches sounds really, really appealing to me.
Cool. Yeah. I think it's probably impossible to automatically generate a CSS selector because the computer can't like know exactly what the user is thinking, or like so it'd be interesting to, I think in the end maybe the programmer really does need to choose the selector themselves, or be given provide enough information to help them choose that selector. But yeah.
So Jeffrey, you're presenting some of your own work on this at some point. Have you already done that, or is that still to come?
Yeah, my talk was at Onward like an hour ago, or in 11 hours from now, if you want to stick around for the long haul. Yeah, and sort of connects to Rebecca's work a little bit.
Yeah, I realized my question was probably earlier was, in a way, I guess you've got at one end of the spectrum, you've got kind of web services, haven't you, which is just kind of exposing kind of application functionality. And then right at the other end, you've got kind of gestural kind of UI interactions, or just glancing with your eyeballs at the screen. And everything along that spectrum is potentially a kind of interaction that you could have with a kind of service of some kind. And I guess you've got to pick your focus of interest, because they're potentially, there's maybe value to sort of consider each of those points.
Cool. I'll try to check out your talk later, Jeffrey, if I can find it on the on Clowder.
Were the Onward talks being recorded? You said it was an Onward talk?
I think they were, yeah.
I think they were, yeah.
Okay.
I can pop a link into the Zoom too if anyone's curious. I think like I've been trying to work on sort of the layer of like, if someone has made a beautiful scraper that links the website to some more semantic information, then what can end users do with that? And so I think it's exciting to see this kind of work, because I would hope that people would be able to share these scrapers that they create, and maybe other people could remix them and doing their own automations or things like that. I think would be interesting.
Yes, is there a kind of machine learning work on kind of mining user scenarios out of kind of the interactions that they?
I think there was one submitted to the Uppsala, but it was rejected. But it was a really great paper, so I was for accepting it. But yeah, so, and it was really interesting to actually try to solve the problem Rebecca's work wanted programmers to solve, and just writing the selector. But they, in their approach, is that, hey, what about if we pointed to a website and say what we want to have extracted, and then try to throw machine learning at it and they will generate us the program that will extract it. And eventually the programmer had to select about like, this works, this does not work. And sometimes, so it really often worked. That was very impressive. But I guess for programming language, something, it was too much magic. And it was too much magic, but it was great magic.
Can't have too much magic. So I've noticed that this year there's a fair bit of kind of live stuff going on elsewhere at Splash. I mean, Jonathan just posted something, but there's obviously Jeffrey's talk and quite a few other things kicking around, I think. Yeah, and I guess we've got these other workshops which are kind of starting to overlap already. You know, Plato's obviously been running for a long time anyway. But I guess gradually these things are becoming more mainstream, more kind of just what people expect of their tools.
Rebecca, I'm curious if you have any thoughts on, like, I feel like web automation had a big heyday in like the early 2000s, and seems to be like a lot of that initial energy seems to have died out to me. And maybe there's a small renaissance happening, I'm not sure, but I was curious if you feel the same way, and if you have any thoughts on like why that happened. Or...
Yeah, I think I know what you mean. Like there's like CoScriptor, like 2007, I think, or something, and like some other papers like that around there. I mean, I think there has been stuff recently. This is kind of related to web automation, like Toby Lee from CMU, like his work on intelligent assistants, like so like a kind of an automation script of some sort is generated based on users like demonstration examples or natural language hints. So yeah, I mean, I'm not sure why. Yeah, maybe why there was a dip. Or do you have any insights on that? I'm relatively new to this area. I've only really started working in it this year.
Yeah, I'm not. I only have loose speculation. My theory would be that sort of the ROI wasn't there in terms of like it just the use cases people could come up with weren't valuable enough, and like, you know, mapping houses on a map or whatever, you know, web mashup.
Yeah. I think I know what you're talking about.
Sort of like were like interesting demos, but maybe not useful enough for people to actually put into practice. I don't know. That's just a theory.
Yeah.
I'm curious.
Yeah.
Also, I think you're right that all the programming by demonstration work, web or not, sort of fits into it. It seems to me like there was a lot of excitement around PBE in the 90s, and I'm also curious about why that sort of hasn't seemed to have become super popular. I don't know. Maybe you or others here have like.
Maybe it has also to do with that the interesting things you can do with web automation is also the first thing the people try to prevent you to do, like the Google example, or like when you have say, oh, now I know how to do this by hand on a web browser, and you start even by automating it if you are a programmer and try to convert it to a curl or a script and use it in your Unix shell in automation, and you immediately run into, okay, we blocked you off because you are a machine, you are not allowed to do this, we want to sell you our advertisement and keep our data. And so every very, very interesting things are locked off that can be automated. But on a different note, I found a good counterexample where there was a nice bridge of using a website to actually programming it or automating it. The new Microsoft Academics website was where you could enter, because I was frustrated with the Google thingy and failed to automate it. I looked for the academic thing, and there, when you open it up, you could see, oh, what is the website doing, and then you could by watching it see that it would like use semantic queries and the web services and got exposed to like I could look what the website is doing and then just do that. And it really worked and was a nice way from getting me from using the website to actually like hacking a little bit the website to then progressing to, okay, I now register at Microsoft and use the official API thingy, because they built somehow their website tool with little programmable parts that could be composed together, or at least was the real thing. And this was a nice way of actually like, okay, using a website to starting in the programming scripting world.
Sorry, I missed what you said. Is it like does this tool help you record some of your actions, or provides?
I just used the web browser and pressed the Chrome and see what network things were happening when I pressed enter. And these things, I didn't have to interact much, but just like could figure out. So, but they had some very semantically way of doing a query and querying an object that contains the result still as an object, and then using that object in the UI to build the UI locally. I could then say, okay, but I'm fine with the object level result and use it myself. And this is much better, like a query that would, on the other hand, the negative thing would be, okay, give me a full rendered HTML page and I have to parse things out of it again and these things. So I could hook into this, oh, here is this nice object level. I go on here, I'm fine now.
Got it. That's cool. Yeah, that seems cool because it's like, it's kind of like a small trace of the thing you're like, it kind of zooms in on the thing that you're actually interacting with, as opposed to like this huge DOM, and it's like, how do you find the relevant elements or something? Okay, yeah.
And I think at least the direction of building software that way is still like approach, like the whole Microsoft Graph or other SAP Graph and the things they try to like expose their internal services or internal programming more like on that way, and then later hook the UI on this. And applications that are built in such a way seem to be much better like programmable, and you don't have to only get through the UI but say, oh yeah, this is UI level and there is a still readable thing, and then you don't have to like say enter this in the input field and then send a click to the button.
Right. If only, I guess, all websites had that nice exposed API.
Yeah, one related thing I've thought about is how, you know, some apps have a pretty good like command architecture already. Like in Photoshop, you have your undo stack, and everything you do, you can see it, it's there, the list of the things you did. And I wonder if that's sort of a good foundation to build on for, you know, if you're always seeing your actions represented visually, then moving to automating in terms of those actions seems more natural, as opposed to if I'm used to just interacting with a UI and my actions have no ramification, then it seems like I've tried using AppleScript, for example, and it's really hard because I'm used to using Finder and I have no idea what I'm technically doing in the language of the system when I'm clicking around there. And then I start trying to script in AppleScript, and you know, what is it? What is it called? Open? Is it called like click? Like, what are the verbs? What are the nouns? I'm not familiar with the object model of the system, even though it is exposed to me through AppleScript. You know.
But as you mentioned, AppleScript, it used to be better. Like 10 years ago, when I was an Apple user and had my fun with AppleScript, there was still some applications there that were built in a very nice way, where you could expose this, and then they had this Apple Automator thingy where you say, yeah, this is a new end user tool where you replace this AppleScript language and everything is automated. And even they had a demo case of using PDF files where they could like here, drop in the PDFs, and then you could extract the notes and then put it into the spreadsheet. And this, look at what a great workflow this is. And when you tried it out yourself, looked at the API, what they exposed there was, oh yeah, I can actually only get at the notes of the PDF. I cannot in any way get at what I have selected and all this. And they really tried to hide really powerful information that was accessible to the user and already there in the UI. And it was not there in the automation.
Yeah, I've seen that problem too. But on the other hand, you know, there are some, like some of the Apple first-party apps do have really good AppleScript APIs. And on the Windows side, like a lot of apps have really good COM APIs where you can access, like in Autodesk Inventor, every little box you're building in your 3D environment is accessible. So I think it's not just a matter of having those APIs. It's like we also need to think about, you know, how to familiarize people with those APIs in the context of normal use so that the slope to automating is can be much more gradual.
What do you think? Did they just don't bother to build this in? Or for example, in the Apple case, it was the Apple Preview PDF tool, I could enable the support for disability support and screen reader support, and then use AppleScript to actually use it like in a web page, say, select this button there and this, and I could get that information I wanted to, just not in the API that was provided. But didn't they bother to implement like AppleScript support or Automator support? Or is it so that they don't want people to use their tools in such a way? So what is it?
I mean, my Occam's razor opinion is it's far more common that people just don't invest the resources to do that. I think it's rarely adversarial, like especially if the fundamental, you know, the reason apps have good AppleScript support is if they use Apple's object model in some canonical way, then you sort of get it for free, right? And I think if you have to like do a lot of work to bolt it on, then you don't have too many people using automation. Then it makes sense to me that it would be low priority.
So do modern Apple apps still support AppleScript? So for example, I think they replaced iTunes, and iTunes had a great or mediocre to great API for AppleScript. Does a new music app still support AppleScript?
Good question. I don't know the answer.
I think just to jump in, it's, as you said, Jeffrey, the minute there's any kind of burden on implementers to go to an extra level of kind of indirection and sort of reify the operations that they're implementing, it's just unlikely to be done unless there's some kind of intense customer pressure for them to do it. Maybe what we need is is for that to just be the kind of medium that we work in somehow. Like you mentioned, just kind of idiomatically using the object model in a certain way. Well, if the only way you can build apps is to use the object model in that idiomatic way, then you're already exposing and reifying all your services kind of to the end user. So maybe that's what we need, something like that for web apps, where you build a web app in a kind of transparent way.
Yeah, I mean, one thing I've noticed is some web apps that use the Redux library or sort of the Elm pattern already specify global commands and global state. That sort of is a semantic model of what's going on in the UI, right? And sometimes you can access the Redux dev tools in a production website, and you can manually trigger things like make an order or like create a new blah, blah, blah as, you know, semantically meaningful actions because they've already built the whole app that way. And I think sort of piggybacking on that sort of existing framework is an interesting, it's more likely to happen, I think, than trying to get websites to build in that way just for automation. I think you need it needs to be a broader value proposition.
I wonder if maybe another reason software companies might be hesitant to expose that those APIs is what if they decide to change their API and it's just then there's they don't want to have to provide a nice way of helping people making it compatible or something with people's prior usages of it. So I wonder if that could be if people were to more consistently expose their APIs, if that would be another problem for us to try to address.
Yeah, and I suppose maybe going back to Jens's point, maybe people are just paranoid that users will come up with weird ways of using their applications that are kind of going to take over, or either some denial of service type thing, or just creating some new business model that just yanks everything away from whatever their revenue stream was. It's just kind of, it's a bit too risky to open everything up, even though it's, you know, I think we all want it.
Yeah.
Yeah, that's a really great point, Wrecker. Around, I mean, the prospect of like making every internal API in my UI into a public API that I now have to like preserve compatibility on is yeah. I think you're totally right about that. I wonder if like my take on this is that basically, I think we're going to have to live with sort of someone has to do the work of taking this ever-changing UI and mapping it to a stable API, and there's real work to be done there. And I think like there's a JavaScript library called Gmail.js, where a community of maintainers maintain a stable API on top of the Gmail user interface for browser extensions to talk to. And there's enough browser extensions, including companies that use it, that they, you know, when Gmail changes, they jump in and update to maintain the stable API. And the economics of it work out so that there's like enough people who care to do the work. And I wonder if we can think about how to like orient things so that someone is incentivized to do that compatibility maintenance work, even if it's not Gmail themselves, you know?
Yeah, that'd be great, I guess, especially for like large websites or like commonly used software packages or something. Yeah.
Yeah, I think it's both common websites and also like it doesn't work if the API can only be used by one browser extension, because you know, like there has to be some sort of like genericness to it, I think, to incentivize enough people to care. Yeah.
So we are lucky that the web is somehow structured text and not pixels, so that we can access some UI. So for example,
not in the Canvas world anymore.
When you look in the realm of game modding, they have a similar problem where eventually you could want end users to hook in your games and interact with them and do fun things. But on the other hand, like the companies profit from these things. And some companies, on the other hand, say, okay, we don't want this, maybe because we want to sell it ourselves, and try to really make it difficult to get at the real thingy underneath and do everything to protect their data, their software, and from the hands of the users. So maybe that can also be seen on web apps. So eventually it would be cool if everybody could script it, but on the other hand, they say, oh, maybe we don't want to, because we don't want to give anybody control except ourselves about our data and things.
There's probably some analogy to like biological systems, aren't there? Like there's always a kind of balance between sharing information with the environment and kind of hiding information from the environment, because anything you expose can be exploited by somebody else. But you can also convey information, you know, you can manipulate your environment by revealing information to it.
Yeah, I think there's sort of a common theme here of like, the thinner the client, the harder it is to hack things. So like, yeah, going to pixels is bad, but even in the current web, like, great, you have a DOM, but 90% of your data is on a server somewhere and it's not living in your browser at the moment. So it's hard to query it. It's hard to access it really at all. Maybe you can like construct some API calls to the website's backend to like fetch all your data or index it or something. But like, because our clients are so thin, I think it makes a lot of things tricky, as opposed to like hacking local desktop software. If you can find the folder that has all your data in it, that's a better start, you know?
Thanks for the question, for the discussion. I appreciate it. I'm going to head off for a quick break before the next talk starts, but nice to see you again, Jeffrey.
Yeah, I can see you again too. I'm going to log out. Thanks for the discussion, everyone.
So Jens, are you presenting at all?
I don't present anything here.
Some of your colleagues are, right?
Yeah, Patrick and Fabio just was presenting this live paper in that other session.
Yeah.
And Graal.
Hi, Rolly.
Oh, that's perfect. So, how you doing?
A little bit tired. I had my first session at 5.
Oh, ouch.
And the next one's going to be at 4 in the morning, but okay.
Why was it at 5? Because you were...
I had to get up at 5 because I chaired the session very early.
Okay. Oh, I see. Yeah.
But the 4 in the morning thing, didn't I read on Twitter that it was nobody has to get up at 3 if he does not want to?
That's only Uppsala. Because the Uppsala process was not shared. I mean, for ECOP, it also didn't work.
So, okay, for Uppsala, the authors had a saying and they didn't want to present at the night?
Yeah, because I mean, you don't know where they live, so you don't know when their night is. So you have to ask them, when is your night?
Yeah, but somebody at least knew that your night was at 4 a.m. So
not really.
Is there a method somehow to shift you in a way that you don't have to get up at 12? No, at 4 in the morning?
How would anyone know when it's night at my place? It looks pretty bright here, right?
So when
but maybe that would be a thing to consider next time.
So they don't give you any options about what slot you chair. They just say, "Would you like to chair?"
Yeah, that was my mistake. Oh well, no, I was being nice because that slot was kind of not very taken. Although we had people from all around the world, that slot seemed to be not very popular.
What was this onward?
The slot, do you mean, or the session?
What conference was it?
ECOP. Hideko was actually with me, but I think it was a better time for him.
Yes.
it was noon, right, or something like that.
It was I don't yeah, 2 p.m. or 10 a.m.
Yes, it's easy to kind of, even when you're just locked into your one time zone, to kind of start to lose track of what time is it.
Yeah.
Been looking at
being in Asia, this 12-hour mirroring is some kind of advantage to me. Otherwise, this workshop or the other workshops, almost all workshops are going on in night time in Japan.
Mm-hmm. Yeah, so the workshops are hard for you, but the conference is quite effective for you, right? They're 12-hour. Because for me, the workshops are doable, but they're in the late afternoon to evening. But then I can only really do one of the 12-hour talks. But for many of them, there's only really one I can catch because the other one would be at 4 in the morning or something.
Yeah. But Hideko, how does this time slot work for you? This must be also in the middle of the night for you.
Yeah, it's 1:50 a.m. So I would probably taking off during the next session.
That's probably wise.
In the COP workshop, we started a little bit earlier, but that had the effect that actually nobody from California was there. But since we had nobody on our list from California, we said, okay, let's start with Chile. This is a good time zone in the morning. And then it was nicer for the people in very far east.
So Hideko, the poly canon or poly squared canon?
Poly squared canon.
Yeah. So the non-polyglot one, there's a kind of pure JavaScript version, right?
Yes.
And how, I mean, it looks pretty cool. So how kind of universal is that? Can you just use that with any JavaScript code and any data structure, or is it kind of restricted in certain ways? Or
So currently, it only supports one file, one class-based JavaScript programs, and also the programs that generate a small amount of objects because of the little bit slower visualization part. So we need to improve the performance. But so at this point, it's pretty experimental.
You can basically create a small number of classes that all create instances of each other, and then you can just visualize those kind of networks of objects, essentially.
Yeah. So at this point, our visualization basically uses the JavaScript reflection API, so it just traverses all the objects reachable from the global variables. So if we created 1,000 objects, then actually the Canon engine will traverse those 1,000 objects 1,000 times during the program at each point of the program execution, which is quite inefficient.
At each point, it traverses the entire object graph.
Right.
The number of times equal to the number of nodes in the graph.
Right.
Because
we cannot instrument into libraries.
Oh, right.
So for example, if you use the library function in array, then we don't know what will happen. So we just decided to traverse everything at each point of the user program execution.
Right.
So the next version we will use the modified virtual machine, then we can more efficiently monitor what's happening inside of the program.
Right. So are you planning to use Graal or something, or?
Yeah, Graal. So truffle Graal. So the idea of using the truffle is that you can implement many language virtual machines by writing the interpreters in a truffle framework. So if we little bit modify that language implementation, then we can easily instrument the object creation and object modifications in a language universal manner. That's basic idea.
The Graal will allow you to hook into object creation and stuff like that.
Right. So we just use the Graal VM just as a kind of polyglot reflection programming language.
Right. Yeah, so in a way, the polyglot part of it is kind of secondary to the reflective part in a way, because reflection is kind of more powerful to you, isn't it? Polyglot's nice, but it's a kind of bonus.
Yeah.
The nice thing is that you don't have to know about how reflection is implemented in that language, because it's on the level below that.
So is it the level of Graal bytecode or?
Yeah, there a Graal reflection API on the Java side, and
so actually, what at least the part we are using is for every AST node, you can ask for what kind of role it plays. Is it something you can call? Is it something you can store into? Stuff like that. I mean, the list is a little bit different as far as I remember, but then you can, for example, for us, it's very easy to just say, give me everything that can be called, with a definition of something that can be called. So that's something where we can put examples to add to something like that.
So can you intercept the kind of point at which that node is being executed? Is that something that it?
Yeah, you can, and that's pretty. It's pretty impressive. Like the truffle instrumentation framework is just, it's a dream. It's a dream come true. Yeah. It's really amazing, and it's also fast. I mean, that's just.
Yeah, is it fast once it's kind of warmed up, or is it fast from the beginning?
Yeah, I mean, because it can, as far as I understand it. Okay, Fabio, for example, could be, or Hideki would probably also know more, but as far as I know, it is really good into just integrating your instrumentation into the execution as if it was part of the program.
Oh, so it's optimizing the instrumentation as well, because it treats it as just stream of bytecode presumably, and it's just optimizing both. Is that the idea? That it doesn't really distinguish meta code from user code? Or?
So that's the point where I'm not sure anymore.
Well, the original idea of Growl is to make the efficient Java JIT compiler to be available in many languages. And in that way, they invented the AST interpreter-based language implementation. So the language designer will write the AST interpreters, and then the Growl will use that AST as a kind of intermediate language just on top of the bytecode or the intermediate code to generate the native code. So, since that AST framework is pretty common in many languages, we can also use that AST representation as a kind of a reflection tool to instrument some code.
Right, so I guess like Patrick's example with there are things that are callable and things that are instantiable and so on, and that might be
right.
Right. Yeah, I might have to look more into Growl. So there are kind of R and Python implementations for Growl as well, aren't there? But I guess they run into the difficulty that a lot of the core R and Python libraries are written in C.
Right. So Growl, they have a LLVM implementation on top of Growl. So any C code can be compiled by LLVM and then interpreted and then the JIT compiled into native code in that framework.
And on the Python side, I know that they are hard working on getting NumPy done because that is and get it fast also.
Like it fast and portable, that would be a kind of done deal then, wouldn't it? Okay, I think we should be starting again soon. I'm just waiting for Brian.
Yeah. I think we're missing two of our speakers still, but the first speaker's here, so Steven's here.
Hello.
Hey. Yeah.
Shall I go ahead and start
you can start screen sharing whenever you like. We'll still wait a couple minutes, a minute or so until
okay, sounds good.
Until starting, but I'll say a couple quick words.
Okay. Can everybody see this okay?
It's not full screen. If you're trying to do full screen, I don't see full screen yet, but otherwise I do see a screen fine. Yeah.
Fantastic.
All right.
Okay.
All right. I'm gonna start recording again. Oop, I stopped by accident. There we go. Start recording again. All right. Thanks everybody for coming back, and welcome to our second of 3 talk sessions. And just a reminder, we're going to have another break between the second and third session, and then our less official 4th session will be a social in GatherTown, and there's a link on the live website as well as I think on our researcher page, and we'll be sure people get that if you want to come and just hang out and have some optional pub trivia. Right. So this session will have four full talks. Each talk will be 12 minutes long and then 8 minutes for questions. So 20-minute slots. Right. And then if you haven't filled out our attendance form yet, I'll drop that in the chat. We just want to keep track of everyone who's coming in. Right. So our first talk today is from Stephen Mackey, and he's going to be talking about lineage, fine-grained lineage in Jupyter notebooks, so we can have safer code and not get lost in state and forget about state that's not there, right? So he's currently a PhD student at UIUC, interested in improving user workflows for machine learning and data analytics, and especially bringing in some of the ideas from the database community. So Stephen, take it away.
Thanks so much, Brian, for that nice introduction. So I'm delighted to come to the central time zone again, this time from the West Coast. So even though I'm a student at UIUC, I've been visiting UC Berkeley. So I'm going to talk about MB Safety, which is a drop-in replacement for Jupyter's Python 3 kernel. The goal is to make it easier to reason about out-of-order execution in computational notebooks. And actually, I just remembered that I have this talk recorded. So I'm going to go ahead and just play that for you all. Should be a bit smoother. Starting now. To first motivate why it's worth the effort to spend time improving notebooks, let's first briefly recap some advantages offered by a notebook programming environment. And since Jupyter in particular has become super popular and has won all kinds of awards and accolades, we'll focus on it during this talk. First, when prototyping ideas, notebooks allow you to incrementally refine code in a cell and rerun it until it's correct, keeping intermediate state in memory the whole time, unlike IDEs where it's hard to observe the effect of your changes without a bunch of extra steps. Next, by allowing users to mix rich text documentation with code, notebooks offer a great medium for presenting experimental results and for providing tutorial-style documentation. And finally, the ability to generate plots inline and tweak their presentation without losing progress is a true game changer. That said, the key advantage of Jupyter and other notebook environments, which is their ability to keep intermediate state in memory and at the ready, can also make them hard to reason about, since this intermediate state is global, hidden, and accumulating over time, and as a result is really hard to keep track of manually. To illustrate this difficulty, let's just consider a simple example notebook where we have 3 cells. We first define a function, call it, then print the result. If I change the function definition, but forget to rerun the middle cell before running the print statement at the bottom, I get a stale result from my output because the Y that was printed depends on a call to an old version of F. And while this example is a bit contrived since the 3 cells are right next to each other, keep in mind that notebooks can become quite large and unwieldy, and it's not uncommon to have these kinds of dependency chains spread out over time and space. Keeping track of how how cells depend on each other is thus a burden shouldered by users who might end up making mistakes that actually can be really subtle, so they might not even realize sometimes that there's an error. This has prompted some backlash against results presented by a notebook medium in the Twitter sphere, with folks saying things like restart and run all, or it didn't happen. It seems as though there's a safety interactivity dichotomy where if we allow ourselves the interactive benefits of going back, editing cells, and running them out of order, we give up on safety and increase the likelihood of errors. While if we force ourselves to be really disciplined about running each cell exactly once and in order, we can be more confident about our results, but give up a lot of those interactivity benefits. As a result, my collaborators and I developed MB Safety to address some of these concerns. To illustrate it, let's look at how MB Safety behaves for that same simple example from before. Recall that I have 3 cells. I define a function, call it, then print the result. Using the MB Safety kernel, if I change the function definition in the first cell from x plus 2 to x plus 3, MB Safety gives me 2 kinds of highlights. First, the last cell gets a stale highlight because Y depends on a call to a previous version of F. To refresh the staleness in Y, MB Safety recommends that I rerun the middle cell by showing this refresher highlight. If I take the suggestion and rerun the middle cell, now the stale highlight shifts to the output of the last cell, and to refresh the stale output, MB Safety suggests me to rerun the last cell. When I do so, I get an output that's semantically correct given the implicit dependency structure between these 3 cells. Let's take a look at under the hood at how MB Safety accomplishes its magic. MB Safety uses a runtime tracer to build the implicit dependencies between symbols appearing in the cells, and then it uses a program checker to alert users of cells that are unsafe due to staleness, as well as cells that can resolve staleness. Let's look at how the MB Safety kernel instruments a single end-to-end cell execution, as depicted in this diagram. The first step is user submits to the kernel a cell for execution. During cell execution, the tracer looks at each statement as it runs and builds up lineage or data flow dependencies between symbols appearing in the executed statements. Here's a quick example of the tracer. In the cell on the right, the first statement that executes assigns 42 to symbol A. So when it executes, the tracer sets symbol A as having no dependencies. The next statement that executes assigns to X a list containing two constants as well as the symbol A. And since A appears in the use symbols on the right-hand side of this assignment, MB Safety marks X as having dependency on A. And we also have a bunch of other rules for ascribing lineage or other types or data flow for other types of statements, such as aug assigns, function definitions, class definitions, and others. And I also want to mention that this lineage is only computed for statements that are on the actual path of execution. So the untaken branch of an if statement will not induce any lineage metadata. So that was a quick example of the tracer. Let's look at how the checker then takes metadata from the tracer and identifies staleness issues as well as staleness fixes. To illustrate the checker, let's look at another quick example. Suppose the symbol foobar is stale in this cell. That is a dependency of foobar changed, and foobar has not yet been updated to reflect the change. To detect that this cell is unsafe, MB Safety performs liveness analysis to compute symbols that are live with respect to the beginning of the cell. In this case, there are two such symbols. Symbol num, whose value before cell execution is used right away, as well as foobar, whose value before execution, which recall is stale, could be used in this print statement at the bottom if either of the branches here or here in the if statement are taken. So that was how we use liveness analysis in conjunction with runtime lineage metadata from the tracer to detect stale usages. How does MB Safety determine staleness fixes? One strategy could be to determine whether concatenating pairs of cells removes live references to stale symbols. For example, suppose symbol Y is stale in the simple notebook depicted. Y is clearly live if we restrict our attention to the last cell, but if we append it to the cell before it, Y is no longer live at the top of these joined cells because it is immediately killed in this assignment here. This is exactly what we need to determine that the middle cell is a refresher for the stale usage in the bottom cell. Unfortunately, this method of computing staleness fixes or refresher cells requires us to run liveness analyses on all pairs of two cells concatenated together. And this does not scale for large notebooks. It's kind of quadratic complexity. Instead, we make use of another analysis technique called initialized variable analysis or definitely defined analysis. If we go back to our previous example, this analysis would tell us that symbol S is definitely defined by the time we reach the end of this cell because it is assigned in every branch of the if statement in this cell. So if S were stale, initialized variable analysis would tell us that we could run this cell to resolve any stale usage of it. The same cannot be said for symbols foobar or foo if they were stale, since they are each only defined in one branch of the if statement. And so if either of them were stale, the staleness could potentially linger on after we run this cell. This initialized variable analysis only needs to be run once for each cell in a notebook. So we no longer have that quadratic complexity if we were to use liveness analysis on its own for computing refresher cells, that is. So finally, we already saw how the front end leverages these analyses to present cell highlights to the user that alert them of both staleness issues and staleness fixes using those highlights from before. So in the interest of time, I'm not going to go into too much detail on our empirical study, but in short, we scraped 666 real Jupyter execution logs from GitHub that contain richer interaction metadata than what is available from static notebook snapshots alone. And we found that MB Safety suggestions correlated well with real user behavior. The y-axis of this chart just shows the likelihood users picked different kinds of cells. So in particular, this chart shows how likely MB Safety and users were to arrive at the same choice for what to execute next, independent of each other. In particular, refresher and newly refresher cells were very likely to actually be cells that users chose for execution. So they kind of agree with the choices suggested by MB Safety for what to execute next. The other cells that users were likely to pick for execution next were fresh cells, cells with live references to newly updated symbols, as well as newly fresh cells. So cells that just recently contain live references to updated symbols. So MB Safety also suggests these kinds of cells for execution. And these were much more likely than other kinds of baseline cell types to be picked by real users, even though the users weren't influenced by the choices of MB Safety. On the other hand, stale cells were unlikely to be cells that users chose for execution. And when we looked at particular examples of sessions with stale executions, we found that oftentimes users seemed to be confused and would do things like execute the same set of cells over and over as if they were wondering why they weren't getting the output they were expecting to see. That concludes this presentation. So be sure to check out nvsafety.org if you'd like to try out our stuff. It's a one-liner for installation, and we of course appreciate any feedback, GitHub stars, and so on. Thanks very much for your attention, and I'm now delighted to open the floor to any questions during the breakout session happening next. Thanks very much.
Great, thank you very much, Stephen. So if you have questions, you can either drop them in the chat and or raise your hand and then you can throw them at Stephen.
Thank you very much.
So I had a question right away. At the end there, you mentioned that users seem to be stuck, like they didn't understand why things weren't changing. Do you have a sense, is that because they should have been rerunning some of these stale cells that they just didn't touch? Or is that just is that a hypothesis? Or
Oh, okay. So let's go back to that example, which I think is sort of representative of what was going on. So yeah, if we look at this example here, the user might, for example, change. Actually, we'll look at it with the NV safety semantics since it's easier to see what's going on. So like, let's suppose the user changed the top cell here. Then they might rerun the bottom cell and be confused when it doesn't change from 4 to 5. So they see 4 again. So then what we would see is they would jump back up to the top cell, try running it again, and jump to the bottom cell, run it again. And they would do this several times. And this is, of course, not this particular example never happened. It's just representative of the types of confusion that we saw when we were looking at these execution logs.
So you haven't been able to put NV safety in front of people yet to see if it helps their confusion?
So we have not performed a user study, if that's what you're asking, which we would like to do at some point. It is actually available for anybody to use though right now. And I don't know if I should mention this since this talk is being recorded, but I actually used it when I was generating the plots for this work, and one of them maybe would have been wrong if I hadn't been using it. So
that's good, at least a good initial validation.
Sure.
Jeffrey has a question. I can read it out. He says, I'm curious why you require users to manually rerun stale cells instead of automatically keeping all the cells reactively updating.
Yeah, that's a good question. So I guess I probably shouldn't try and do this live over the air, but there could be cases where there's multiple choices for what to execute. So let's suppose I have x equals 0, y equals x plus 1, y equals 7, and we'll run this again, and then x equals 42. So if I print y, I get this warning, right? Because y is stale, it depends on a previous value of x. In this case, I could rerun either the y equals 7 cell or the y equals x plus 1 cell. And so we really, since there are oftentimes multiple choices for what to run to refresh things, we wanted to leave the user in control and preserve existing notebook semantics as closely as possible.
And I'm guessing users do that sort of thing because they want to
Yes.
have these, they use it like a stateful button sort of thing. Like I have these different states, I want to try different ones, and I realize they conflict.
I think determining that determining that would require a full user study. I can at least say that for myself, this is how I use notebooks.
Okay. An existence proof.
Right. Sure, exactly.
Raleigh, Jeffrey, do you have anything you want to say about that, or otherwise we'll go to Raleigh. All right, cool. Raleigh, I think you have a question. You're muted, sorry. Yeah.
Okay, sorry about that. Yeah, thanks a lot, Stephen. Really enjoyed the talk. So my question is about your plugin, which you described as a kind of replacement for the Python 3 kernel. So I'm wondering what happens if in that user code they call out to a kind of Python library. Are you going to be able to instrument that, or is it only if that Python library is written in Python?
Oh, that's a good question. So if you mean like for other modules that users are installing. Okay, so because I'm going to present a simplification of the state of the world, which is that we only need to worry about staleness issues between variables defined in the global scope of the notebook itself. Okay. If we use some libraries, we don't need to trace the library code. This isn't 100% true because there are things like there's that cell magic. What is it called? I'm blanking on it. The one auto reload. Yeah. There's this thing that will actually let you import your own files. And if you do that and then change those files, it will automatically reload symbols that are defined in those files. NV Safety doesn't work with this yet. We would like to make it work with this at some point, but that is going to be tricky to get correct. So we're still thinking about it. But for non-auto reload case, we don't need to worry about other library code.
So when you say within the same notebook, do you mean including kind of fields of arrays as well?
Yeah, we that's why I called these symbols actually instead of variables. I wasn't sure what the best way to refer to that is. So if I have oops, let's go ahead and import NumPy. And it tells me even from the import, I can do that. Y equals x sub 0 plus 5, print y, and then x sub 2 equals 3. So this shouldn't show y as being stale after I mutate this entry of x. But if I mutate x sub 1, then because y has a dependency on x sub 1, it should show y as being stale. So things like subscripts and attributes are also given lineage metadata in NV Safety.
Thank you.
Sure.
You have any other questions? Any last question? All right. If not, are the mighty people, did you guys make it? Are you all here now?
Hey.
Great. Excellent.
Jake here.
Right.
And Aaron and Nate should be here as well, I believe. There's Aaron. There's Nate.
I see Aaron. And
hey.
Nate is the in the white t-shirt.
Got it. All right. Excellent. All right, great. So you guys ready?
Yeah, awesome.
So so now we're going to have Jacob Diamond Ravitch and other colleagues from Mito are going to show us their programming by demonstration system for creating Python code by working on a spreadsheet.
Yeah, totally. So maybe I'll start with giving a little bit of background. So recently graduated undergrad business school at the University of Pennsylvania, although it was quarantine graduation, so I'm not sure if it actually counts or not, but we'll see if I ever get the diploma in the mail. And so undergrad business school, I don't know if any of you did that, but a lot of spreadsheets. We kind of, I guess, gained a little bit of a passion for spreadsheets just, in 4 years of using it in finance classes or whatever. But spreadsheets, I think, are kind of limited in some ways, but also offer a lot of opportunities. And so we started building spreadsheets tools for finance, really like Excel add-ins back in June, May, I would say. And I guess for two main reasons, we really strayed away from that. One is that it's pretty hard to develop in the Excel environment. It's pretty limited. Everyone's ever tried that, but it's not the best experience. And then two is the finance community, I'd say, is a little bit harder to get feedback on and really, build a grassroots tool around than, say, the data science community. Like, you would be hard pressed to hop on a Zoom call with this many nice people in the finance, this many bankers in the finance community talking about tooling. So definitely happy to be being in the data science community a bit more. But so the tool we're making, it's called Mito, and it is a extension to Jupyter Notebooks that lets you edit your data frame as a spreadsheet, and every edit you make translates back into Pandas code that you can use for reproducibility and extensibility. So let me share my screen and we'll just jump into it. There we go. We're used to using Google Meets for all our calls. The Zoom interface is much nicer, I will say. Cool, so here we're in our Jupyter Notebook, standard Jupyter Notebook. This is actually our website. So alpha.try-Mito is sort of our self-hosted place where we do these things. And I'm actually on the wrong tab here. Cool, here we go. All right, and so I'm going to run this cell, and just quickly to, I guess, acquaint you with the Python it takes to get Mito up and running. So this Mito sheet, you have to have everything as a data frame to start, and this Mito sheet.sheet call is what renders your data frame into the Mito sheet. So we're passing in df1 and df2, and you see when you pass in multiple data frames, they appear as different tabs in an Excel workbook type. That's sort of the analogy, I guess, we're going for. And so yeah, here's your data represented. We have the column names and the actual data. And the first thing we're going to do is so here's data set 1 and data set 2. And we see we have this user ID that sort of links the two. And the first thing we're going to do is we're going to merge this together. And so this is our take on sort of a SQL type merge. If someone's familiar with using SQL, that's sort of what we designed our merge after. So we have what sheets we're using, what the merge keys are, and then we can also select which columns we want to keep from each sheet that we're merging. And we're going to keep all of them for the purposes here. And we'll merge them. And then that will create a new data frame with all of the data together. So sort of like a SQL merge inside a spreadsheet, inside a Jupyter Notebook, if you can wrap your heads around that, which certainly took us some time to do. And then here you'll see this is the generated code from what we did. So this is that merge step here generated in Python. And as you'll see as we add more steps, that we represent this code in a stepwise feature or setting to make it a little bit more readable and understand the steps a little bit easier. And so I wanted to show you sort of some of our formulas. So I'm going to add a column here. So we say add column, and I'll just quickly show you that adding a column creates a step 2 where we've initialized that column. And let's put a formula in here. So let's say we have the user ID. Let's say we want to take the 3 left characters from the user ID. So we use our left function, and we can pick user ID 3, and we get the 3 left characters from the user ID here. So doing a bit of data cleaning here. And we'll notice that step 2 updates with the formula of that column. And then I guess I'll just quickly show you some of the other formulas. Let me do a numerical one. So I will add another column here, and let's make this total visits divided by weekday visits. We get this number here, and yeah, we'll see the df3 there. And now what we can do with this new value we have is we can do some filtering on this data. So let's say we want to do anything that is greater than or equal to 3. Filter down, and we'll see our data set shrunk a little bit. Got some of those values that were lower. And we see this filter is kept on here, or noted that it's kept on here by the highlighting there. And we'll see the equivalent Python here for that filter I'm just looking at the time here. So let's, I think another feature that'd be great to show is sort of our pivoting functionality. Something pivoting we've heard just from the users we talked to, and I'll talk a little bit more about our users and who we're engaging with at the end of this, but pivoting is something that definitely can be a bit of a pain point for people in Python. So we have our own take on it here where you can choose. So let's say we're going to pivot on the user type. So you see we have free and paid users. And we're going to do the sum of the, oh, oops, I'm on the wrong thing here. Sorry about that. We want the user type, and we're going to do it on the sum of their G value here. And we'll group, and we'll get a new data frame that has this value. So this is our pivot feature there. And then the last thing I'll show you is what you can do is you can actually, and this is sort of going after the repeatability part. So you really only have to do this process once if you're going on a repeatable analysis. So we can save this analysis we've done here as, let's call it test 7. And now if we have similarly structured data sets, so you can imagine here a process that you're doing, it's like a data cleaning process you're doing daily, monthly, weekly, whatever the cadence is, and you get similarly structured data maybe coming out of a CRM system or something like that, and you wanted to rerun that analysis every time, but you don't want to have to do the code each time, or you don't want to have to do the steps in the Mitasheet each time, we save our analyses. I can run this cell, and now I can rerun this analysis on this cell here. Oops, why? Let's just rerun a different one. Cool. This is a different saved analysis, but yeah, we can see. So this was a merge step. But you see, I had this merge here saved, and now I can rerun this merge as a sort of like a saved macro, Python macro inside of our Mitasheet. And so yeah, this I think is sort of gives you a range of the functionality we support. Lots of spreadsheet functionality used for data cleaning or data manipulation. And then just, I guess, with the last maybe 90 seconds here before we go into questions, we'd just love to talk about sort of where we're at as a project. So we've been posting on lots of subreddits. We've been fortunate to be at the top of like Excel subreddit, which was like definitely a new community for us and things like that. And so we've got a lot of signups. We have a wait list of people waiting to use the tool. And we have about 40 active users right now using it. And it's a broad range of people. And the interest is really twofold. The primary interest is as sort of as a process automation tool. So you can imagine it's like a VBA macro, but it's with Python. And I think the advantage there is too, I think a big counter argument we get a lot of the time is like, why not just use VBA? And there's two things. One is that being backed by Python instead of VBA opens you up to a lot more speed and robustness that VBA lacks. And then two is that there's so many packages associated with Python that we can tap into that VBA doesn't. So we're not at that functionality yet, but you can imagine in the future, incorporating machine learning packages that would be much harder for something like VBA or Excel to handle. Lots of different advanced analyses that are already in the Python environment that we can tap into because that's where we exist. So yeah, that process automation is the first one, and the second is we've seen it as a great learning tool for Excel or for Python rather. So people are going to come in and remembering Pandas syntax is really hard, and this actually saves people. We've heard from just talking to our users a lot of trips to Stack Overflow, which is maybe one of the biggest pain points there is in terms of using Python. So yeah, those are the use cases, and I could talk more about the users, but I'd love to open up to questions. I think would be now.
All right, let's thank Jacob. Yeah, it's great to see programming by demonstration in a setting where you're trying to actually make a practical tool for people to use, and you have users trying it out. Yeah, it's great to see. So, does anyone have any questions they'd like to ask? All right, looks like Ravi got his hand up first, so take it away, Ravi.
Cool, thanks for the demo and thanks for the talk, really nice work. This reminds me a little bit of Mary Beth's nice keynote earlier today where she mentioned her and her colleagues' work on Mage, which was also trying to basically interpret spreadsheet actions as code like this. And one of the challenges that she mentioned was that because each user interaction is being interpreted as code, the code basically keeps growing and growing and growing. And so I'm curious to find out whether there's kind of any future plans to try to like refactor or clean up the code that's generated in case users want to, rewrite it in a way that's either easier to understand or abstract in the future, or whether you think this kind of like, individual interpret each interaction as a new code snippet is the kind of long-term way to go.
Yeah, it's a great question and something we've definitely thought about. I would be remiss if I didn't have Nate chime in here because he definitely thinks about them most.
Yeah, definitely. It's a really interesting question. So I think there's two kind of points to highlight on. The first one is that users understand their actions translating to code in a very direct way. So essentially, like we experimented a bit with like, we call it code block optimization, where we kind of, you did a bunch of things that result in only one transformation at the end of the day. Let's collapse those. And ultimately what ends up happening is users say, I don't understand, where did my code go? So I think there's essentially from a usability perspective, there's a real strong argument for just keeping it as a linear list of actions. From a maintainability, understandability perspective long-term, especially as we begin to think about repeat analysis and kind of running these workflows, there is definitely kind of an optimization argument. But the way we're thinking about it currently is definitely as a user opt-in. The user chooses to go through an optimization process that results in kind of a new script. But making it manual allows them to kind of understand what's actually happening versus all of it happening behind the scenes. It's something that we got burned on a couple of times and we confused the hell out of some people, I'll tell you that. Yeah, good question. Thanks.
Cool, that makes sense. Thanks.
Yeah, that's a really interesting insight. Raleigh, I think you had a question.
Yeah, hi. Thanks for the great talk. Yeah, so my question was about the kind of operations that you were applying when you were creating formulae. So it seemed that most of the operations you were kind of creating there were kind of column-wise, if you like, rather than row-like. Mm-hmm. In a spreadsheet, you kind of typically you put a formula into a cell, and if you want to apply it to a column, that would mean kind of essentially copying that formula down the column, or maybe dragging it in using one of these fancy kind of Excel features. So I kind of like the emphasis on sort of column-wise operations, because I think that's often what you want to do. So I was wondering, that then suggests, well, is there an opportunity to kind of develop a new kind of spreadsheet interface that supports that a bit more naturally, as a style of programming? Because it's something you very commonly do in data sciences. You operate on arrays and tensors, and you lift operations to operate on those kind of vectors. And that's not something you can commonly do in spreadsheets, but it seems like you're kind of heading that way with this. And I just wondered if you had any thoughts on that.
Yeah, it's a really great point and something we definitely thought about. I think you really mentioned, I think, the crux of it, which is like, this is a spreadsheet geared for data science, not necessarily geared for the types of analyses you do in Excel. And for that reason, yeah, a lot of these data sets are really large, and you're not going through at a granular level and changing every row. You're really applying a stepwise process, column by column, to achieve some output. But yeah, and in terms of optimizing, I think with your point, making a spreadsheet that really is geared towards that column, column framework. I think we're kind of on that path now somewhat. We've definitely had thoughts about allowing row edits, being able to go in and change a particular piece of data. That's actually a feature that people have asked for, where it's you're doing some data cleaning process and you want to go change one piece of data that's messed up for some reason. Doing that in pandas can be a little bit of a nuisance, but going into a spreadsheet and just finding that row and clicking a button and typing in a new editing something is actually pretty easy from a an ergonomic standpoint. So yeah, I think right now we're probably optimizing for the column-wise feature, but I do think in the future we will support a bit more flexibility, even if that's not the goal of the project. I think just having that option will be really kind to the users.
Thank you.
Mark, you're up next.
Thank you. Great talk, guys. Really excited to see you working on something that's so polished.
Nice.
I'm interested to get your perspective, as I know at least one of you are business school graduates. Maybe the others are involved in that space as well. I'm really interested to get your perspective on how the people in that world have been receiving this work. Maybe not everybody, but I know a number of the people here are from more of an academic perspective. We're used to seeing these sort of program transformations, code generation. Is there an excitement about this, or have you needed to convince investors and users and the various people you're talking to that, hey, this is really worthwhile? Or how does that conversation go?
Yeah, that's a great question. I would say it's very industry specific. So I think generally there is an excitement, especially moving from spreadsheet workflows to Python workflows. The way we've seen is often I guess in business there's sort of this like spectrum of like business analyst who uses Excel to data scientist who's very heavy into Python, and they're often trying to do similar tasks, but just their skill set leads them to a different medium. And we've seen sort of just a trend in like pushing that skill set up a little bit more generally towards things like Python. One of the reasons is there's just so much more data available in the world, and like using big data in analysis is growing day by day, and Excel is not geared towards large data sets. 1 million lines of data is the strict limit, and for most people on their computers, trying to do anything with 100,000 lines of data on Excel is pretty abysmal. But I think the interesting question that we've come up against is or not come up against, but just experienced when talking to business people about it is, especially ones who are interested in Python, the question is like, are they interested in Python because they want to learn Python, or are they interested in Python because they want faster processing? They want to be able to do these analyses they're already doing in the spreadsheet, but on larger data sets. And we think our tool kind of meets them in the middle there, which is, you can, if you don't want to interact with Python that much, you really don't have to. It takes this one line of Python here, mitosheet.sheet, to render the data frame, to render the mitosheet. You can do all the edits you want, and then you can save that analysis and never have to touch the edits even again. So it's sort of saving, you can interact entirely within the mitosheet for 95% of your workflow. But then also, because we're giving you the code, it gives you the option to then go, you either learn Python from it or incorporate this Python script into a larger code base. So yeah, I think that there definitely is an interest, but there's a spectrum of people who really want to learn Python or really just want to, I guess, increase the efficiency of their workflow.
Thank you.
All right, I think we have time for Ravi. You had another question.
Thanks. Yeah, so following up on all of those great points about how this can be a really great way to kind of teach and learn how to write Python code. I'm curious. So I think right now, like in the generated code, there are these like do not edit kinds of comments. In the future, I'm kind of curious about how you're thinking about going about allowing changes to the program itself and maintaining the connection between the code and the output. Ambiguity and that kind of thing is a big challenge in this space. I'm kind of curious about how you're thinking about going about that.
Yeah, I'll give a little bit of light, and then Nate, maybe if you want to chime in, or Aaron. So yeah, currently, definitely when we set out, I think we were thinking a lot about this like two-way bridge between Python and Excel, and just from a I guess for lack of a better term, because I hate to use this word, go-to-market strategy. We've really been focused more on the spreadsheets to Python, sort of a one-way highway. And that's just made building a little bit easier. It's made the mental model for our users much easier as well, specifically in the markets that we're talking to. But in the future, we definitely do have ideas about how to make it a little bit more of a two-way bridge. And Nate, maybe you want to chime in here.
Yeah, I mean, I think in the general case, this is unsubstantiated, but it's an unsolvable problem in the general case, right? Transpiling a piece of Python code back to a spreadsheet edit. There are, of course, like there's a limited subset of the language you could probably operate on to get backwards, but we didn't design Python, and we didn't design Python for a spreadsheet, so it's a little bit hard to go backwards. I think there's one interesting point here, which is how much the backwards direction leads to learning generally, right? Because the flow through seeing the Python code that's generated is very helpful in terms of learning Python. But the other thing that's really helpful is editing the Python and seeing what changes that might make and how that compares to the mental model that you have. So there's definitely reasons we're interested in it. It's a very costly, expensive thing. And, we're living on ramen right now. So we're trying to get it to a place where it's usable rather than a place where it's perfect. And I think this is kind of the first thing that goes out the window from like a real practical usability perspective. As an ideological interest thing, we love it. It would be cool as hell. but it's not so particularly useful to our users. So
yeah, I would piggyback off that, in that there was a lot of things from the beginning where we were like, oh, this is super cool, we want to do this, we want to do this, but really over time we've become more interested in what our users are interested in, which I think has ultimately been very beneficial for us.
Yeah. Thanks for the questions.
Cool, thanks.
Yeah, let's thank the Mito folks once again.
Yeah, thank you. I just want to say I would love we're a free tool, so if everyone, I'll drop our link to the website in the chat. But if anyone wants to use it, please do. We'll get you set up very quickly. But thank you for having us.
Yeah, you're welcome. Please do that.
Thanks.
All right. So next up, we have Dimitri Cordon talking about functional block programming and debugging. So Dimitri is a postdoc at the University of Geneva, very interested in programming languages and compilers, and he's going to be showing us a programming environment called Funblocks.
Sorry, seems that I have.
Yeah.
Oh, I need to reload to grab to Zoom. I'm back in a sec. Sorry.
All right, so we'll wait a moment.
All right, sorry about that. It was about our permission issue. Thank you very much for an introduction. Everyone can see my screen, right?
Looks good.
Excellent. Thank you for having me. I will talk to you about our latest project, is Funblocks, which is an educational tool to teach programming. So before maybe a little bit of introduction, we were wondering how we can teach programming. So what I mean by programming, or my working definition of programming, is that it's a set of activities that consists of designing a program that has to run on one machine. And this includes many sub-activities. It's not only the coding itself, but it is also testing, understanding the specification, simulating the program, and so on. So this is really a kind of a process, and it's difficult to teach a process other than just ask people to do things. But at least maybe we can try to find the best way to start this learning process. So how do we start it? Well, you can start with a real programming language. These days, Python and JavaScript are very popular, so we can pick either of these languages, for instance. They are dynamic, and a lot of people will claim that they are simple. But my experience is that, in fact, it's really not, especially if you work with young students or even children. The problem is that what they are used to work with is not as rigorous as a programming language. Even if you write mathematical formula on a piece of paper that are eventually meant to be written by a human, it's okay to make slight syntactic mistakes here and there, whereas in a computer, you really need to be extremely precise. So one way to alleviate this problem is to rely on what I would call user-friendly code editors. So Scratch is a very popular option that is tilted toward children and education of programming at a very young age. And these kind of tools are always based on the same kind of idea. It's a visual programming language, block-based, and you just place blocks on top of each other, and this represents the stacks of your program. The issue I take with this approach is that now you always have an imperative paradigm underneath. So that means your programs look something like that. It's a list of statements. Most of those are assignments into some kind of variable. And then you have predefined functions that let you interact with the environment. Either you can print something or maybe move a character in a virtual environment if it's like a kind of game and you need to code this game. But this begs the question, what is this program actually doing? And if you're learning programming, this might not be obvious. And if you ask students what this program is doing, you will get most likely two kind of answers. And actually both are completely correct. So I guess most of you guess the first one, that's E0. Congratulations, you are thinking like a Python programmer. Obviously, we assigned 0 to y, we assign the value of y to x, then we modify y, but it doesn't change x. So when we print x, we get the value we got at line 2. But we've been looking at spreadsheet before. So if you have the semantics of a spreadsheet in mind, then 7 is a correct answer because x equals y is just a reference to the value of the reference of the cell y. And then if you change the value of the inside the reference in an Excel spreadsheet, for instance, this makes sense, then x will change. So now we see that there is already kind of misunderstanding about the semantics. So even if it looks very simple, this is only 4 lines of very, very basic code. It can still lead to confusions with young children. And even if you say, well, let's forget about that. This is really just forget about spreadsheet and stuff like that. It's programming. We know what the assignment operator is. Well, I can raise you with other kind of tricky situations. Here you have a program where you allocate an object, and then you change a field of this object. And same, you have 2 variables, and you make aliases between these variables. So now what is the output of this program? If you, once again, both answers are correct. If you say that it should be a plus of 2, congratulations, you are still thinking like a Python developer. But if you think it should be 1 and 2, then yeah, you're right. This is the value semantics you would find in languages like Swift or C, C++, and things like that. So here, it's really a semantic issue. It's not only a syntax issue. So that means even if you have a very nice environment, so this is a kind of a scratch code that you will get, that completely forgets the semantics difficulty. So now you cannot make semantic error, just place blocks, and this program has to be syntactically correct, excuse me. The semantics is still the same problem. We have all the assignment issue that we've just mentioned, and we also have to learn a bunch of other control structures, such as loops and conditional statements, whose semantics is not clearly defined within the language itself. I just need to know, I need to learn what a loop means. And this can feel really overwhelming. So our approach was to start from the basics with 2 very, very simple questions. First, what is the data, and what is computation? So very simply, data is anything that you can declare. With a declarative approach, anything that you can state being, that is a data. A blue square is a data. So what is a computation? It's a transformation of the data. For instance, turn a blue square into a big circle is a transformation. So now I have a very, very super high abstraction. I don't need to care about the implementation specifics. I just want to express that there is a mean to translate this blue square into a pink circle. And now I have a tool that I can reuse to explain other kind of transformation. I can turn a blue square into a pink circle. I can turn a pink circle into a green triangle. And I naturally have a way to compose this different transformation. In fact, I have a transition system, if I want to speak in technical terms, but I don't even need to know that. I just have a bunch of rules, and I can apply these rules to reach a specific goal. I can also have the same framework used to create even stronger abstraction. Let's have 2 rules that really look like each other. I want to turn a blue square to a pink square, or a blue star into a pink star. Well, in fact, I just need a rule that transforms a shape into a blue shape into a pink shape. So now I've created another layer of abstraction very easily, very intuitively. And this is in fact polymorphism. But if you go to educators, computer science educators, and say, well, we will do polymorphic functions with young children of 12 years old, they just think you are crazy. But in fact, this is what you can do with this kind of approach. So how does it translate in our tool? So we also have a block-based kind of approach. So this is the visual syntax we have for language, for Funblocks. So it's basically terms. This is the basic currency of everything in Funblocks. Everything is a term. So it's basically a functor and a bunch of subterms that represent the arguments of this functor. You could think of this as a function and the arguments of this function, but maybe this function doesn't have explicit semantics. It doesn't have to be have a semantics. It's just here a statement of something. It's a data. And then you can have transformations of these different terms. For instance, here I have this ask transformation, and this is a rewriting rule that transforms a statement into a question. Everything works by pattern matching, so I just need to check on the left side, or here the top part of the rule, if it matches the term I have, and if it does, then I can just rewrite it, and this is the only operational semantics I have to know in the entire framework. What's interesting is that using this, I can even explain the other kind of control structure that I've mentioned before, that with an imperative approach, I need to already know. So for instance, here, I can define what it means to execute a conditional statement. Notice that the then and else here are written with squares rather than rounded rectangles. This is because they represent variables. So here, these two different rewriting rules describe both branches, both possible outcome of a conditional expression, and you would match the then and the else block with whatever terms you have, and then you could instantiate this rule, this particular rule, for any kind of term. So maybe I'll get to a quick demo. A lot of viewers were very eager to have a demo of the tool to see how it goes. So here it is. It's still early stage of development, so the interface is not so sexy at the moment. But basically, it's an editor that lets you drag and drop the elements that you have on the left. It's kind of a toolbox, and then you can create your terms here just by placing things and drag and drop things. So for instance, here this would be description of a list that contains the number 1, for instance. And now we could write a rule that rewrites something that is a list of something. So let's say here, instead of this, I will place a variable. So a list of anything is written to this particular thing. And now I can, and now I can hop into the debugger, and I can try to apply my different rules on the program states, and it will evaluate my program. And I can go back to the states. But I think I will show that with a more involved example. And there's one other addition that we think was very interesting in our tool that we found in other similar approaches, was to have a hybrid version of both the visual syntax and a textual syntax. So we can hop into the textual syntax here, and we can write directly a program in the textual form. And all the changes I do here have a direct impact in the visual representation as well. So I can, no, I made a mistake. So I could, for instance, write here a second rule. It's actually the same, but I can see that I can edit my program in both versions. So if I write something a little more involved here, this is the concatenation of a list. And I go here, I can see how it goes. Obviously, because we chose to have the states develop horizontally, there is a clear problem of the interface, but we can double click on something to make it smaller. And so this is how you can manage larger states. And now in the debugger, you can try to play with this and see how you can reduce your term using the correct rule. If you don't use the correct rule, then there is like this visual indication that you made a mistake. And basically that's it. So the things we are working now is to try to define a type system for this. It is really obviously a bit difficult because type systems are something a little more difficult to approach with children or very young students. But we are trying to find ways to make it a little hidden and maybe take insight from gradual typing so that it doesn't have to be something that you need to define. It could be something just additionally included in the tool that some educator could use as they see fit. And that's all I've got. Thank you very much. And I'm happy to take any question.
All right, thank you, Dimitri. So does anyone have any questions for Dimitri? You can raise your hand or pop it in the chat. I have a first question. Can you do capture avoiding substitution?
It depends on the way you apply the rules. So yes, you can, but you need to be careful about how you want to apply the different rules you want to do. The automatic strategy, I didn't have time to show it, but the automatic strategy just runs everything, and then you could have you could capture something.
All right, Raleigh has a question.
Yeah, hi. So, yeah, so at the beginning you described, you kind of asked two questions. You said, what is data and what is code? And you said a data is a thing and kind of a computation is a transformation of a thing. But I guess one way of characterizing functional programming would be to say that transformations are also data. So I was wondering whether that's also on your kind of agenda. Are you thinking about higher order data?
Mm-hmm. I think it would be cool to have a higher order transformation rules into the system, but we felt that it added a lot of complexity to something that was already powerful enough to be an explanatory device. The thing is that we don't plan on Funblocks being an actual tool to do actual programming. And we don't plan on Funblocks to be something to explain really complex stuff about functional programming in general or typing system in general. It should really be something, our vision is that it is something as an introduction. And once you get into it, and maybe you try to work with the textual language, you get comfortable with the textual language, it's time to move on to something more involved, and maybe it's time to move on to Haskell or another cool functional language that lets you explore all these complex questions more in depth.
As a kind of transition to a textual language rather than a programming language.
Exactly.
Okay, thanks.
I definitely appreciated that it was bimodal. Simon has a question.
Hi, just wanted to say really love the talk and love the slides and love the demo. I was just wondering about the kind of type system aspect of it. So I guess in Scratch, you've got, these repeat blocks where you can just only plug something in. I mean, you can't plug wrong things into wrong things. So, I mean, is there any way that you could kind of marry that mode of interaction with a type system so you can't, say, add Booleans and floats?
Yeah, this is exactly what we want to do, actually. The thing that we are trying to achieve is to have this gradual ID. So at first you have completely dynamic types and you could put anything in any space. But once you add your types, there is kind of a reward in the sense that now you cannot put an int where a string is expected or a list is expected. And this would support the idea that, well, if you type your program, then you will catch more errors. And we have this, this feature that we are working on right now, which is a tool that will, analysis that will catch whether your rewriting rules are defined for all cases of the types that you gave, because you can give like a recursive definition of a list, and then you have this cons and empty that I quickly showed before. And then you could use this analysis to check that all your rules are defined for all possible cases, and so that you cannot end up in unresolved states.
Oh, I see.
So this kind of analysis could be used to help the students understand the consequences of the rules they write and the full type correctness that you can get from a type system.
So I guess later on it could be, if you add in kind of algebraic data type things, some types, and you could actually look at totality of type checking and things like that. That'd be really cool. That'd be great. Yeah. Thanks very much. Cheers.
Thank you for the question.
And then last short question from Rolly.
Yeah, I just had a very quick follow-up to Simon's question, which is a really, really nice question. Yeah, I guess if you could define a kind of recursive data type like list, you could almost imagine designing that as a visual shape, like a sort of stencil that you can only compose in certain ways. You know, you can compose it in a kind of iterative way, but you can't compose it in a kind of typing compatible way. So yeah, I think that's a great question that Simon asked, not mine.
Yeah.
All right, let's thank Dimitri again.
Thank you very much.
So now for our last talk of the session. There's always a kind of a name collision when we talk about live programming. There's people who actually work on code, and then there's people who write code live to make music. And now we have an intersection of those coming together where we're going to have a musical talk, but also using program synthesis techniques. So Mark Santalucito, assistant professor at Barnard College at Columbia University, is going to talk to us about exploring human-in-the-loop program synthesis with live coding. And I'm looking for, my ears are looking forward to this talk. You're muted.
Okay. Can you hear me now? Yes. Okay.
Excellent.
Thank you for the introduction. I hope my ears can live up to your expectations. Right, my name is Mark Santalucito, and I'll be talking about exploring human-in-the-loop program synthesis with live coding. That's quite a mouthful, so the first thing I want to do is just break down this title to figure out a little bit more about what we're talking about here. So I see this as three different components: the human-in-the-loop, the program synthesis, and the live coding. So I want to work from the bottom up here and give a little bit of context for what I mean by live coding. And as Brian said, we have the sort of two different interpretations of what live can mean in this context. We have live programming and live coding. So I'll be talking about live coding here. Live coding, I like to say, is the act where the active programming becomes a critical part of the end product. So in live coding, we're actually not pursuing software engineering to get to a final state of the code, but the evolution of the code itself is what we're interested in. So Nick Collins, a famous live coder, calls live coding the art of reprogramming, changing your mind about a process once established. And so what this actually looks like, you can see here a little pre-COVID picture from Baby Castles, a performance venue in New York City. Messica Arson's performing live coding, and you can see the artist has their laptop and is coding. The code is on the screen being projected. And live coding is this performative practice where the audience listens to the music that's being produced, or the visuals that are being produced, or whatever media is being produced by the code, as well as watching the evolution of the code. Now, there's a lot of overlap between live programming and live coding. They're not really distinct, and live coding doesn't have a really solid definition anyway. But I like to look at live programming as more of an IDE design principle, where we're saying we want to bridge this gap between our code and our output and our interactions. And live coding is one particular instantiation of that, where we're leveraging live programming. Doesn't necessarily need to be that way, but in most cases, live coding, you can think of live coding as taking place inside of a live programming environment. Okay, and then a little bit about program synthesis. We've sort of been dancing around this idea of program synthesis all day. I'm going to be talking about program synthesis in the sense that given a formal specification, we want to generate code that satisfies that specification. And in this case, the specification could be a logical formula, could be input-output examples. We're all familiar, I'm sure, at this point with flash fill from Excel, the classic input-output example use case. But I want to focus specifically on these two directions, Cygus and in particular CVC4. So in recent years, there's been a an amazing amount of progress in the program synthesis domain, especially in standardization and tooling. And I think this is what's really exciting. This is, to me, once tools and processes start to become standardized and have good support in their tool sets, we can do interesting things. So I'll talk about syntax-guided synthesis in a little bit, as well as CVC4, a SMT solver that supports syntax-guided synthesis. And what I'm really looking at is trying to explore how we can leverage general purpose program synthesis tools in live coding and live programming. Okay, so right, general purpose meaning Cygus. Okay, and now finally, let's just touch on this human in the loop aspect of program synthesis. So human in the loop program synthesis really is just everything that we've been talking about today. But from my perspective, when I look at program synthesis, I see that program synthesis is guessing too much at what the user wants. We provide a specification, and then really we're asking too much of this black box. And so what we want with human in the loop program synthesis is how we allow the user to guide synthesis at the most critical parts of the synthesis algorithm. Now, we've seen this before. Everything today, a lot of the authors of this output-directed programming, direct manipulation interfaces are here in the Zoom room today. So, very cool stuff. The one point I want to make is that prior work has largely been focused on leveraging these code templates and not general purpose synthesis, and looking at the human aspects of human in the loop program synthesis, and not how human in the loop program synthesis actually has an impact on the algorithmic limitations of synthesis. Now, all of this is probably a good thing. We want to be focusing on how users actually use our tools, but there's two sides of the same coin in a way. We can not only benefit the users, but we can actually hopefully gain some insights into how to best structure synthesis by involving our users. So I really like to see this in both directions. And then we also saw there's a lot of challenges in getting general purpose synthesis to work. Code templates are effective in many cases, but how do we push past that? Okay, so before I talk a whole bunch about all sorts of details, I want to hop into a live demo so we can sort of get a sense of what it is that we're going to be working with here. So here I have the tool that I've built for related to this work. This is a drum machine, or a step sequencer. So here we have a block, a matrix of buttons effectively, and we can turn these on and off. And let's see, hopefully you can hear some noise now. And so this drum machine is going to loop, right? So I'm defining a pattern, a rhythmic pattern that's going to loop. And what you'll notice is as I'm clicking on the buttons here, code is already being generated. So we'll get into how this code is being generated in a second, but I just want to demonstrate a little bit of what happens. So here I'm building up my pattern, and you can see code is being synthesized here. And every time we synthesize code, we're going to synthesize code in two different lines, basically a map over an array, and then we're going to splice that array. And I'll get into why we do that in a second. But this is bidirectional, so I can make changes here as well. And now we're getting different code. So I can make any changes I want here. And I get interesting different patterns here. Let's see. And you can fill this with any sort of value. So I'm going to fill this with some code that wouldn't reasonably be synthesized. Okay, and then the other thing I just want to point out is that I have some sliders here that can change the pitch of the drum beats that we hear. Okay, so this is the basic idea behind a drum machine, and as well you can see the code that's being generated and how we could edit that. So let's talk a little bit about what's going on there. Okay, so the code that was being generated was all using as a backend Cygus, which is syntax-guided synthesis. And syntax-guided synthesis, given a grammar of allowable functions, we want to generate a function that satisfies some constraint. And so we're using satisfiability, modular theories, and SMT solver, CVC4, to solve these problems. And this is really important because by using an SMT solver, which is a separate tool, modular tool to our front end of synthesis, we don't need to keep changing our front end. Every time that Cygus synthesis gets better in CVC4, synthesis gets better in our tool as well. So this is following the same sort of pattern that we saw in program verification community, where a lot of front-end tools were being built on top of SMT solvers, and those front-end tools just keep getting better every time the solver gets better. We're looking at a similar space here, and the challenge, though, is how do we connect the code, the direct manipulation editor, and the synthesis queries together into what Cygus expects, which is a space of allowable functions, as well as the constraints. So this is the basic sort of flow of interactions that we have. We initially start with, typically you'll change some notes in your direct manipulation editor, your step sequencer. This is initial synthesis. It will change that code the first time. Then maybe we'll do some manual coding in here. That should then update the direct manipulation editor, and then we can go back around in a circle with program repair when we change more in the direct manipulation editor. So the challenge here is really, how do we move around these three different modes of interaction with the code? So first I'll start about, just talk briefly about how we actually turn these step sequencers into constraints. So this is a bit domain specific. And basically what happens is we have a number of different patterns. The first thing we do is split each track into an independent synthesis problem. We'll just look at the TOM1 pattern right now. And then we generate example constraints based on the time index and the note value. So here we're saying at index 0, we have a 1. At index 1, we have a 0, et cetera, et cetera. And so we generate constraints accordingly in the Cygus language. And one thing you'll notice is that we need to prune, what we do is prune large subsequences of a common value. So we have a pattern here, and the user just hasn't gotten around to clicking all of these buttons yet. That doesn't mean that the user wants all of these to be 0. It just means they haven't been specified. What we do is we say, okay, let's leave those out of our synthesis request. So as you can see here, we only have the first 5 indices specified in our constraints.
About a minute left, so
okay,
so you can wrap up quickly.
Yes, and then we get our function out of that synthesis, and we can then translate that synthesis result into a map over the array. Right, and so this is the high-level idea. We're going to split each track, generate the example constraints, prune the synthesis, and then translate the result. Some of the key limitations right here is that each pattern is unrelated to the other patterns. That's something I'd like to be able to figure out. How do you get all of these synthesis requests building off of each other? We're still, although we're using Cygus for the contents of the map for the actual return value here, we're still somewhat tied to a template in that it is a map over an array. So how do we break away from that? And then finally, this does not scale so well when we run synchronously. So I'll skip over some slides about the issues with running synthesis in parallel. But some of the exciting future to-dos are how we connect this to a hardware drum machine, because I'd really like to have a hardware interface to program synthesis. And there's a number of future questions. So this is all still some preliminary work, but hopefully I can get some great feedback from you guys. And if you're interested, I'll pop the URL here into the Zoom chat. Thank you.
All right, let's thank Mark. That was a lot of fun. My ears enjoyed that.
I'm glad.
Does anyone have any questions for him? Rebecca, it looks like you're up first.
Yeah, thanks, Mark. This was a really cool demo to see. In the demo so far, it seemed like you mostly interacted with the drum dashboard. I'm wondering, I'm not very familiar with the live coding domain, but in live coding, are there scenarios where it would be more intuitive or more expressive or less tedious for people to actually make more edits to the code itself rather than interacting with the UI?
Yeah, in live coding performances, typically you're only working with code. You're not working with a UI at all. And so I guess I was mostly editing the interface just because that's the program synthesis side of things. But the coding interface is, it's a coding interface and you can write anything you want here. It's just JavaScript. So if I were to maybe do a whole live coding performance with this over a period of maybe 10 or 15 minutes, then I probably would want to be doing more editing of the code.
Cool, thanks.
Ravi?
Thanks, Mark. That was a really cool demo, really cool talk. I'm also really interested in particularly how you kind of embed these code templates in the context of your general purpose language. And, we haven't thought too hard about it yet, but I guess maybe one idea is if you imagine, the code template as being the literals in some more general syntax of the language, I wonder if some kind of tracing or provenance tracking during execution of the program to basically, track the flow of data down to those literal code templates, and then from there you can use that to kind of seed your constraints. But yeah, in general, that would be really great to be able to kind of embed these code templates in a more composable and more flexible way. That'd be really great to make some progress there.
Yeah, that's really a very cool idea to actually think about the code templates as first-class citizens of the language. So the example I've given so far, we just write general purpose JavaScript code. Typically, if you're actually looking at live coding, everybody's using a DSL, right? You don't want to be writing out JavaScript code in a performance, but actually looking at that, and so these DSLs often become sort of languages themselves with a whole their own syntax and semantics. For example, the title programming language for live coding. And actually looking at, say, okay, well, that is sort of a template. If we treat that as a first-class citizen in the semantics, how does that connect to the synthesis? Very cool.
Mary Beth?
Super cool work. I've always found synthesis really intimidating, so this actually encourages me that it's maybe approachable and maybe will work if I actually try it. If I'm understanding correctly, are you going to have a drum that somebody can play and then it generates code?
Yeah, pretty much, yes. So this this is a virtual drum machine, but typically these come as hardware. So musicians will have a drum machine box. And so they can type in by turning buttons on and off their drum pattern, but also they can play the drum pattern by smashing the buttons on the drum machine. So what I'd really like to look into next is, and it's actually more of an engineering problem, is how do we actually connect this virtual interface to the physical interface and start to bridge the gap not only between the code and the output, but also the physical interaction of building that code.
And then I think Raleigh will be our last question for the session.
Oh, but you're muted.
Muted again.
We'll get used to this eventually. Yeah, so I had a question about the kind of workflow where you, so as I understand it, you resynthesize the kind of function, and then you sort of translate that into the map over the array. So am I right in thinking you regenerate that each time?
Yeah.
I guess what I'm wondering is, are there kind of use cases where the user might say, actually, I'm happy with that extension, if you like, to the template that you just generated. I want to keep that part, but now just synthesize some changes to that. So like extending the kind of the vocabulary of literals. Or anything like that.
Yeah, this is definitely a top priority. Right now you get a little bit of that in that each drum pattern is treated separately. So when you change one drum pattern, it's not going to impact the synthesis results of the other ones. But it would be interesting to look, okay, well, can we break this up even more fine-grained than that and say, okay, well, you've made some edits, and actually tracking, which lines of code the user has edited, how we, because this quickly devolves into a Clippy situation where we're suggesting edits to your code or overwriting code in the middle of a performance, and the performer says, wait, what happened to all of my code? So there's a very tricky dance to play here.
Thanks.
All right, let's thank Mark and all of our speakers once again. It was a good session. In the chat, I've put the spreadsheet for attendance. If you came in later and haven't put your name in the spreadsheet yet, or trying to keep attendance for the workshops, that we appreciate that. We're going to keep the Zoom room open during the 40-minute break if anyone wants to keep chatting. The next session, our final official session will start at 1 p.m. Central Time, which I believe is 7 p.m. GMT. So we'll have that. That'll be our final session. And then after another 40-minute break, we'll have our social and gather town. All right. Thank you, everybody. If you want to stick around, you can.
Yeah, so Mark, I guess one thing I was interested in, part of the reason for asking that question is I've often wondered with program synthesis, whether there's a kind of sort of avenue of exploration where you focus on kind of changes to the program rather than synthesizing entire programs.
Mm-hmm.
Because the general synthesis program problem is kind of hard because of the space of programs is very big. Obviously, you sort of simplify that when you've got a language of templates that's constraining what you can generate. But also perhaps if you're more generally thinking of the synthesis program as how to go from changes to the output to changes to the program, maybe that's another way of kind of cutting down the search space.
Yeah, I think I think that's going to be one of the things we see going forward with program synthesis, is looking at, there's more to, and this is the whole human in the loop program synthesis thing. You've already made a lot of progress with your previous synthesis results, with the code that the user has written. Don't throw all of that away and try and synthesize something from scratch. The downside to this is that tools don't really support that interface. So how do we, Cygus is a great standardization, but it's not at all integrated natively anyway to existing code.
I see what you mean. So you'd almost have to find a way to encode in Cygus a language of changes rather than directly.
And there are ways to do that. So Cygus does let you specify functions that may be interesting to the synthesizer, and then we'll prioritize searches in that direction. The problem is then you're trying to go from your target language, in this case it was JavaScript, back into Cygus. As long as you're going in one direction, it's okay. As long as you're going to using Cygus and then pulling out whatever you've written there and embedding it into your code, that's not so bad. But if you're allowing the user to write arbitrary JavaScript code, and then now somehow you need to squeeze that into the very small language of Cygus, you run into a lot of issues. So yeah, I'm not sure. The real question is where do you draw that line for program repair or that incremental program synthesis? Is that work happening closer to the back end or closer to the front end? Do we want to try and squeeze it into Cygus, or is that more on the front end tool? Don't know.
Yeah, I guess, your point before about the kind of architecture, if you like, of splitting it into, a kind of stat solver and having these different kind of well-defined problems that can then a whole community can go and do better with. That kind of suggests, you know, a kind of natural partitioning where you say, well, there's a program synthesis problem that there's a whole community, and they can kind of concentrate on that. And if we can find ways to kind of encode new problems that are useful to us in that, then we can just kind of leverage their good work.
Yeah, I guess that does point us in the direction of more front end, looking more at the front end. Yeah, I think once that problem is figured out, we're going to see a real explosion of programs, because that's the thing, like you said, it's a really hard problem to do all the heavy lifting every time from scratch.
Yeah. And it's not how programs actually work, is it? You're never kind of producing a whole program out of thin air. Like you say, you've got a program that you're mostly happy with, you want a small change to that program based on something you're unhappy about the output.
Yeah.
That's the problem you're trying to solve as a programmer. But it's interesting, you touched on how many talks today had kind of program synthesis sort of in the sidelines.
Yeah, yeah. It's cool to see everybody working on more or less the same problem, you know, different angles and variations and little different spaces, but it's cool to see there's a lot of focus on the need for this space generally.
Yeah. We've got more of it coming later as well. But quite a lot. So is your background kind of program synthesis or live coding or a bit of both?
Mostly program synthesis. My advisor was Ružica, so I was really focused on the program synthesis, but I had started at Yale with Paul Hudak, who's doing computer music. So I was hoping to go more of that direction, but of course that didn't work out. Hopefully to, you know, bring them together now. This intersection of live coding and live programming is a very interesting one as well.
Yeah, because it's odd. There aren't, as you said in your talk, there aren't many examples of live coding where people are actually using a GUI to do the live coding, and it seems counterintuitive in a way because it's such a kind of tactile and kind of live thing. You think a GUI would be ideal for it, but I mean, the guy who did Ixi-Lang, I've forgotten his name now.
Yeah.
I remember him talking about, you know, I think he came up with some Emacs extensions that allowed you to have little kind of GUI widgets inside your code. But I think in the end, he just found that got in the way and it didn't help. So he kind of went more towards a textual syntax that was a kind of DSL for his visual patterns, or his audio patterns rather. But still textual rather than graphical, you know.
Yeah. I mean, there is an aspect of when you're performing, you sort of want to have one interface to your instrument, and you develop a virtuosity in that keyboard interface, and it's hard to sort of get away from that and go back and forth. It feels a bit awkward. It's like, you know, putting down your violin and switching to something else.
Yeah, I guess one thought I have when I kind of think about that exact issue is one of the things we should be trying to do in these kinds of very specific domains like music synthesis, say, music generation, going the other way, is one avenue we should explore to kind of come up with DSLs that are really in close alignment with the actual problem domain. But so like this whole business of kind of mapping over arrays is because you're working in a kind of JavaScript world where it's a very general purpose language. Whereas maybe if you had something like Ixi-Lang that was just tailored for expressing drum patterns and you were synthesizing into that, it would somehow, it would be very easy to move fluidly from a visual representation to a more textual one. It wouldn't be such a kind of...
Yeah, definitely. Yeah, I was showing this work to some live coders and they were all asking for the same thing, which is, where's the DSL? I can't write JavaScript code like this on stage.
Because I think that also, I found myself thinking that with the kind of idea of going from a spreadsheet to kind of Python code as well, you know, and looking at some of the issues that come up in Python notebooks, you know, it's
right.
In some ways, Python's a good language for data science because you have these nice kind of NumPy and Pandas sort of APIs, but the kind of core language of Python is actually really bad for data science because it's all imperative and it's not a target for thinking about how to go from something nice and simple like a spreadsheet into, you know, into code. You almost want the code to really look like the spreadsheet, perhaps with some extra details or something.
Yeah. Yeah, it is funny that Python, I mean, there's so many reasons for it, right? But Python has taken off so much, and in so many ways, it's really not the greatest choice.
No, it seems to be, it's kind of like two things. It's kind of like a shitty language with some reasonably nice APIs kind of sitting on top. And if you just restrict yourself to those APIs, it's actually quite cool. If you just use NumPy and Pandas and so on in a fairly idiomatic way. But as soon as you start helping yourself to all the other features that are there, you kind of get yourself into trouble.
Yeah, yeah.
So if you need to take a break, feel free to head off.
Yeah, I'm going to go grab lunch and be back for the next session.
Okay, I hope you're coming back later on.
See you soon.
Cheers. Hey, Dimitri, are you the only person left?
Sorry?
You the only person left?
Yeah, I was chatting on the private chat.
Funblocks is pretty cool, by the way.
Yeah, thank you very much.
Yeah, I'm quite excited. I mean, it's interesting when you described, you sort of said functor and then data values, and that kind of, I guess that's what triggered the kind of higher order thought. You know, it's because one of the things
it makes sense. It makes sense to kind of want the higher order, and there are other stuff that we wanted to add as we were writing this, because our rules like definitions look also like logic programming, so it's kind of tempting to try to hone on this aspect also. But it's we had to make choices, and we said, well, it's a tool for education. Let's stay simple.
Yeah, it seems a reasonable restriction to say it's a first order functional programming language and get good at that, and then it's a separate problem how to do higher order things.
Yeah.
Yeah, because I guess it's interesting. I mean, I've been thinking a bit about this business with kind of array. What would be a natural kind of sort of array language for programming in a spreadsheet-like way, but with these kind of column-style operations rather than kind of cell, row-level operations. And in the kind of formalism that I've looked at, there's a really nice paper by Jeremy Gibbons about kind of a category theory sort of formulation of kind of array calculus, essentially. And one of the kind of primitive operations there, well, one of the ways you set this formalism up is you have various kinds of functor that you combine, essentially. So you have this notion of applicative, which is just a functor where the things in the container are functions rather than bits of data, and then that gives rise naturally to a kind of column-wise operation, because you can think of the way you're going to apply a function to a kind of array of things is you're going to sort of inject the function into the data type that corresponds to the column. And what that does is just put a copy of the function in every row of the column. And then you can apply that column to another column. Essentially.
Yeah, cool.
And there seems to be a lot of ideas today that are kind of
navigate around this. I think slowly but surely people are accepting functional approaches more and more. It took some time to escape from pure theorists and crazy guy who loved Haskell. And I think we can thank the craziness of the language like JavaScript and to a lesser extent Python too. But JavaScript really did a lot, I think, to advocate for the use of functions as first-class objects, because it's common currency in many libraries, and I think now the common developer is more used to think, functions are just other objects that can use functions as I use my integers.
Yeah, and I think that's right, and the sort of data science focus now as well. It's very natural to kind of think in terms of transformations, and you kind of have a data frame, and you're going to add a column to the data frame that represents the sum of two other columns, and you go through this kind of pipeline workflow of transformations. And obviously you don't have to do that in Python, but if you impose that discipline on yourself, you're going to have a much easier to understand output.
Yeah, it's also kind of interesting to me that higher order programming seems to be not as hard to grab for people who don't come necessarily from computer science. If they come from a more physics or mathematical background, they are not so startled when we talk about lambda functions and stuff like that in Python. Whereas if you take your typical software developer who did the standard engineering school, well, they've been taught recursion is a scary story since the first day they started programming. So they really don't want to go into the functional until you can really show them that, well, it's not that hard actually. You can have a recursive function. It's not that hard than a while loop.
I mean, that just shows you how much damage is being done by teaching people imperative programming at a young age. You know, you're kind of polluting their brain, aren't you, with kind of bad memes. You need to get better ideas in there.
Yeah. This was one motivation for the Funbox project, because I've been working in the state of Geneva and Switzerland. They are introducing computer science in junior high school, and
in Geneva.
Yeah, in Geneva, Switzerland. And we're introducing computer science in junior high school. We've been talking with a lot of teachers at junior high school level, but they really don't get this stuff at all. I think they come from this old school computer science engineering kind of background, and they are hardwired to think in terms of imperative paradigm. And for them, you just mention the idea of a recursion, and they say, yeah, it's impossible. We can never do that. It's the hardest thing possible on earth.
Yeah, it's funny what you become close to if you've just inherited this kind of culture, you know. Yeah, I mean, I remember going through that experience myself, I suppose. I learned in an imperative language, and then recursion seemed kind of daunting, you know, and then now it's the idea of programming imperatively seems quite daunting. I'm scared of it. Yeah.
Same story here. No, but I think it's a testament of the impact of your own experience on the bias you have about what is difficult and what's not. And I think there still needs to be a lot of work to be done on the best way to approach this stuff. Because I'm not convinced functional programming is the trump card. Definitely not in software engineering, and maybe not in education neither. And right now, my feeling is that most educators don't have a lot of data to back their claim, apart from personal experience. And your personal experience is obviously biased by the methodology you use, because if you are convinced that functional programming is the way to go, like I would admit I am, then obviously you will try your best to find a way to learn to teach programming with functional approaches, and then you will find some success eventually because you work towards this goal.
Yeah.
So it creates this bias that, well, I was successful, so it has to be the better way. But
so
we need more data on this particular stuff. We really need more data because it's very important that we teach computer science early on, but we need to do it right.
Yeah, I guess it's interesting to wonder what it is that we're trying to do with computer science education. You know, I guess a very negative and I think unhelpful view would be that what we're trying to do is produce workers, you know, that can go out and generate, you know, the kind of money in the economy, and because that's just, I mean, obviously there's nothing wrong with that per se, except that that's just going to perpetuate the status quo, isn't it? If what we're really trying to do, I think, is encourage a way of thinking that's kind of exploratory and kind of creative and allows you to sort of try out ideas and trust your own kind of ability to do your own reasoning, you know, because we seem to be sorely short on people that are comfortable with trusting their own reasoning. You know, we get all our kind of ideas from the internet nowadays, and the nice thing about programming is it's a medium where you can think for yourself. I mean, I guess
that's why I think we need to focus on abstractions. So what I like about what convinces me personally that functional approach is the way to go is that if our goal is not to prepare software developers, if our goal is to teach the basic tools for everyone to know about computer science, then we need to focus about very abstract stuff. We don't care about the details of a while loop, of a for loop. No one cares about that except software engineers. What we care about is this idea of, well, I have data, I have to transform data, and even higher the functions to some extent should be part of this process, because yeah, the transformation itself is a data, and we should be able to think in these terms.
So what are your students, when I can interrupt? So the students you built the system for, what are they? What is their background?
For now, they are high school students. So the tool is for junior high school students. In Switzerland, this corresponds to teenagers from 15 to 19 years old.
So is this computer science or informatics classes, or is it math, or what?
No, it's informatics class, computer science informatics. They already have math classes, and it's an additional courses in the complete syllabus. But it's changing because the program is kind of ambitious. It's not only about programming. It's a lot about data, networks, security, good practices of using computers and everything like that. So it's really a lot of stuff, and so we can't do much, and we don't have a lot of time either, because it's high school. They have to learn junior high school. They have to learn a gazillion things in different domains. So we really need to be modest in what we want to do. So that's why we need to focus on what has the biggest impact.
And do you have any experience yet? So what happened to the students, or did you try it out with students yet? I didn't.
No, we clearly lack actual practical experiments with our tool and with our approach. What we've done so far is to try out with very small groups of students, but the
high school students.
Sorry?
Students or high school students?
High school students, sorry.
So so expose them to the level of high school students already.
Yes. But because, and this is why our data is a little biased, because those junior high school students are already interested in computer science. So they are not your typical 15 years old teenager who just take the class because they have to.
Okay, thank you.
Pleasure. Okay, I think I will grab something to lunch. So see you around. Thanks for the chat.
How you doing? Do you want to unmute yourself?
Hi.
Oh, hi. Yeah, good to meet you. Have you been with us most of the day?
I was here since 4 p.m. my time, so since the start of the workshop here.
Okay, cool. Fantastic. Yeah, it's not. Are you in Germany?
Yeah.
Yeah. So, are you 1 hour ahead of GMT?
It's already. It's almost 8 p.m.
Yeah. So you're going to be able to make it to the social, or is that pushing it?
I'm not sure.
Yeah, it's a long day. So I'm wondering whether this is going to be another secret talk on program synthesis.
You'll see. I would go so far and say it's something completely different from what we've seen today.
Good.
That I do think. But there's Python involved, so it's not that much deviation.
There's what's involved?
Python.
Oh, Python, okay.
Well, I prepared the talk as a video in order to smooth things because I could ramble about this topic for ages, and I don't think that's possible here. So that's okay, I guess.
Yeah, I think that sort of makes sense, given the virtual nature of things. And I guess if you're worried about timing, it's useful to have a kind of pre-rehearsed time. Okay, we'll just give people a couple more minutes. Okay, we'll give people to 1 minute past. We're currently at about 25 people, I think. Okay, welcome back, everybody. Thanks for coming to the last session. So the last session is going to follow similar format to the last one. It's going to be 4 slots of 20 minutes. So 3 talks, 12 minutes plus 8 minutes of questions, and then we'll have a 20-minute kind of wrap up and maybe a discussion about some of the themes that have come up today. So our first speaker is Jürgen Hahn, who's a PhD student at the University of Regensburg. He's a member of the Physical Digital Affordances Group, and he's going to be talking about a system called Sketchable Interaction for end-user customization of user interfaces. Take it away, Jürgen.
Thanks for the introduction. Well, I prepared this talk as a video because to smooth things so I don't get problems with the time limit. So let me set up quickly. Let's see. This one, share computer audio, optimize screen, share. So you should see my screen, I guess. And hear the audio.
From the University of Regensburg, and in this talk, I'll show you our concept of sketchable interaction. Buzzing or fuzzing?
No audio?
The audio is a bit buzzy. Did everyone get the same?
Yeah, it was buzzing for some reason.
I mean, that's just the video.
And I'll show you how to facilitate and
Some of the same.
Sounds like maybe we're hearing the audio through speakers or something.
Yeah. Let me mute myself.
There's a customization with interactive regions. Let's start with showing you what this is all about.
That's a shame.
Or it's getting its sample rate wrong or something weird.
What's the audio channel on Zoom? There's a way to configure where the audio goes, isn't there?
Also, is it online? Because one of us could try and do it if it's online somewhere.
The video is maybe Raphael Wimmer can share it. I don't know. Otherwise, I'd try to do the talk live then.
Yeah, maybe we have to go for a live. Unless
Okay. Then sorry for the delay. Then I'm doing this live. Okay. So I have to improvise now. Sorry for that. First slide. So then let's start again. I guess you see the slide.
Mm-hmm.
That does work now. Okay, fine. Thanks. So as Rowley already said in introduction, I'm here to talk about the sketchable interaction concept, which facilitates end-user customization via interactive regions. So what I want to talk to you about is what is the concept all about? The concept is comprised of 4 main concepts: interactive regions, collision, linking, and effects. And with concrete use case examples, I want to show you how this thing works. So now you should see the IDE, and now you should see sketchable interaction. So it's tailored for end user customization. And what I can do is, in this SI context, I'd like to call it, is I can draw interactive regions. So this palette region to the right is what's currently available in my context. And I selected the open folder region and I can draw it. And because of me drawing it on top of the folder here, the folder opens. And what I can do as well is I can draw this preview region and show you an image of my cat. And the basic mechanics behind this is that the collision triggered some sort of behavior. The blue region in the top left corner triggered behavior that it opens folders, and the green region with the magnifying glass somehow makes image file regions show a preview of themselves. What I can do as well is, I have to switch contexts now, is even more. I can not just collide stuff, I can link properties of such regions. For example, in this demo SI context, I have 3 sliders, a black rectangle, and my mouse cursor. And the mouse cursor as well is an interactive region. And what I can do is, by colliding the mouse cursor with this rectangle and pressing the right mouse button, I link, that's the other core interaction mechanic, I link the relative positional changes of the mouse cursor to the black rectangle's position. And that's how I can move it around. But in SI, you are not just limited to linking positions of regions. You can link all sorts of properties. For example, with these sliders, once I collide the black rectangle with the top slider, I linked the position of the slider relatively to its base, the other slider component, to the red color channel of my rectangle. And now I can freely move between 0 and 255 in the red channel. And just for completion purposes, once I collide all three, I can model all of these. I can create a functional color picker with these core SI concepts. But that's just the tip of the iceberg. That's just how the basic concepts work. I link stuff and they change together. I collide stuff and they how do you say this? They do some behavior. They open stuff. They mutate themselves in terms of data, or they change their graphical representation. What you can do is also that you can automate specific tasks. For that, there is a conveyor belt functionality which transports items. And from here, it gets pretty interesting, because with this, automation becomes possible, and end users who use this context can use simple building blocks in order to model their user interfaces and automate them, or at least partially automate them. That's done by defining a sequence of interactive regions. In that case, I added a tag region. Let's call that to read. And once I put this text file on it and it passes through, it gets tagged for to read. And that's a bug, unfortunately, but never mind. What I wanted to say is that you can automate things with this conveyor belt. And in order to express even more sophisticated logic or more complex logic, is that you can use other building blocks like this splitter in order to split the conveyor belt in two at this position. For example, if I put image there, I can place again the image file of my cat as an interactive region, and it gets sorted to the true value because it's an image. And for the text file, it's of course false. And with this building block, you can model simple if-else statements. And what you also can do is use some merger region like I've drawn here in order to combine the inputs of multiple conveyor belts to collect them at the central output. And for example, if it's not buggy, you can model a loop in that way. And then with this functionality, you can build logic so that users can automate their GUIs, or can, in the first step, build their user interfaces according to their own mental model of a certain process, and then can go further for automation. Okay. Heading back to the slides. So what I've shown you in a quick live demo is that there are interactive regions in the SI concept that can collide in order to apply behavior, apply effects to each other. Additionally, you can link certain properties, or you can link properties between interactive regions so that these change together. That's somehow somewhat similar to the Smalltalk message passing, so that the data which is given to a region is not doesn't follow any rule other than what this particular region in a receiver function implements to do with that data. So basically, every object can get every data, and every object can do anything it wants with that data. Okay, so heading forward, what did inspire this concept? Raphael Wimmer and I had a basic idea, a concept for sketchable workspaces and workflows, which we presented at CHI 2018 in a workshop. And going on from this idea, we significantly extended this basic notion and came up with further concepts in order to make the concept more powerful, especially for end users. So the linking concept I've shown you in the live demo is one of these concepts which we added anew. The basic idea then was inspired by the buffer framework and mobile spatial tools of Isenberg and colleagues, which basically is a C buffer, is comparable to a C buffer and spans the entire interactive surface, and relative to their position, items get enlarged by a factor of 2 or get marked blue or are spatially modified because a buffer is outfitted to a movable tool on an interactive tabletop like in picture 2. And we combined this approach with the properties of substrates so that we come up with interactive regions, previously known as interactive region buffers, that apply certain behavior to things that collide with them, and substrates provide the inspiration for we can change basically everything via this collision or linking. So in this picture, there are 4 substrates, which every higher substrate depends on the substrate below, and this digital medium, computational digital medium, therefore is the inspiration. Sorry, my microphone just turned off. It's all fine now. This is the inspiration basically for how these interactive regions work. Previous work of Kramer introduced translucent patches and dissolving windows. There we took the notion of interactive regions and the drawability from, but instead of keeping them static as a UI, we made them movable and collidable and not so static, so end users can be more flexible in the combinations they actually can collide or link. And last but not least, I'd like to mention Silk, which had the notion of I draw my user interface, but then has a translation step, which made the user interface to a standard GUI widget collection and just made it look like any other software. And we intended to keep the user drawn user interface as the user interface the users actually use, and do not streamline it or translate it to widgets in this case. So how do you implement an effect? I've talked a lot about how this behavior, collision, and linking works, and what you can do with it. I showed you some examples, but basically, how do you implement such an effect? And that's a plugin in this sense. So the sketchable interaction runtime is implemented as a the sketchable interaction concept is implemented as a runtime, and for that runtime you can develop, and you develop plugins. Here is a plugin, example plugin. That's the preview plugin. That's the region we used in order to magnify the image of my cat. And in this plugin, there are some things worth mentioning. So from a user study, I found out that some mechanism like Android's R class is a very good method to tidy up your code. And I inspired my E-class from the Android R class. It's by no means as powerful, but it does its job in order to neatly tidy up constant definitions.
Yeah, we should probably have to wrap up fairly soon.
Okay, what you see here is the boilerplate code that the runtime needs to see, needs to have in order to actually make it work. And here you see the implementation functions for what shall happen once regions collide. They are on enter, on continuous, on leave events. And we have the guideline to only mutate the receiver of such a function, because as you see capability, the keyword that is used in order to emit or receive such a function, and the receiver always mutates itself. There are some exceptions to this rule, but I intend to remove them in further SDK versions. So that's my talk. Sorry for the delay in the start, and I'm looking forward to your questions and the discussion. Thank you.
Thank you, Jürgen. Okay, so we've got some time for questions, so please just either post them in the chat or raise your hand. Okay, Mark.
Awesome talk. Thank you so much for presenting this. I'm curious, it's a really nice interface. I'm interested in where you see this going. If you find application outside of this, outside of just traditional computation, for example, like gamified learning or something like this for younger students.
Learning is an area in which I thought about to do more stuff, but the first idea we had, the sketchable workspaces and workflows, was intended for use in administrations, in public administrations for knowledge workers, for example. In order to break this need for having 5 different kinds of program software open at the same time. So I have my Excel sheet and I have to copy stuff from there into Word, and then I have to send it per email, etc., etc. That's just so some context. And what also is some goal of this work is to break this up, to unify this. Basically, you can build plugins yourself which do this work for you in your desktop environment. So maybe I'm sure all of you have seen that this is some sort of desktop environment, although it's not integrated in the window manager. It functions as a desktop environment. And with these plugins, you have this behavior in your environment and have the power to combine this as you will. And so breaking up this application boundary is some goal of this
Very cool. Thank you.
Concept.
Okay, we have a question from Jeffrey now.
Hi, love the talk. I was wondering, this strikes me sort of as similar to the Unix piping concept. You have these little utilities, you can see the data flowing between them. Do you think it would be fair to say this is sort of attempting to bring Unix pipes to end users, or is there more? Are there important differences from the Unix composition model?
I target effectiveness before efficiency. I would argue that once you do a shell script, it's fairly fast executed and it runs fairly fast. And an end user who has not necessarily the background in programming can't do that as easily, or has to do a lot of research in order to do that. With Sketchable Interaction, as I said, I have the goal that end users can define this logic, and I chose the approach by drawing. And the efficiency part comes with end users see what happens because they either manually do it or they see on the conveyor belt the data which is transferred. And they can't stop this at any moment, which is not the case in a Unix pipe. So the comparison somehow works. It has this notion that you can automate stuff, some sort of piping, because you can do multiple interactive regions behind each other on the same conveyor belt. But also you have this visual and this simulated physicality, as one of the reviewers said for this talk, which makes it more graspable for end users to actually understand what happens and to build a better mental model about the whole process and how it's to be worked.
Jürgen, I have a question. Is this an extensible framework in the sense that a user could plug in their own define their own interactive region and specify what happens when it collides and what effects it has on its inputs and so on?
Yeah, that's I had to do that rather quickly in the talk, but I can elaborate on that now. So an end user may not be necessarily capable of coding the Python plugin themselves, but some kind of end user, power user, application developer can. And the runtime I developed based on the sketchable interaction concept is fully capable of accepting every plugin you can come up with, as long as it is in Python and follows the Python rules and libraries, etc. In order to encapsulate some kind of logic in an interactive region, based on enter, on continuous, on leave events.
Okay, I think we'll take one more question, and it's Joel.
Hi. Yes, this looks really interesting. I'm wondering so there's the file system that you showed being accessed at the beginning, where the way you seem to bring in existing things from user system is through the file system, which is a common ground for applications to communicate with each other. So you can bring in files from the file system. Is that the only way that artifacts from outside this system are brought in, or that the user's underlying operating system can be accessed? Is it just through files, or can it do other things as well, I guess?
Currently, I only tested it with File.io, but from tests I saw that you have access to the whole standard library of Python. So nothing stops you from importing OS or sys and do stuff with that. Basically, you can also do stuff which breaks everything with this. So you have access based on these modules down to the OS level, sys level. And then you can creatively use them in your plugin as you see fit.
Okay, thanks.
Okay, let's thank Jürgen again. Thank you.
Thank you.
And our next talk is Sam Lan, who is a PhD student at UCSD, and he's interested in tools for teaching programming and statistics. And he's going to show us a live programming environment for developing explorable explanations called Data Theatre. Over to you, Sam.
Hey, everyone. Can you hear me? Is my sound coming through okay? Okay.
Yep.
Always an incantation I need to do in order to share Keynote. Let me see if I can remember the right magical words. Is that showing through okay?
Yeah.
Yes.
Okay, great. All right. Thanks everyone for having me. My name is Sam, and I'm in this project called Data Theatre. I'm a student at UCSD, where we study how we try to design new tools for instructors that teach programming, statistics, and data science. One type of educational narrative that we're interested in understanding more are what we call explorable explanations. Explorable explanations interweave text and interactive demos together in a single web page or perhaps a collection of web pages. For example, one notable explorable called The Parable of the Polygons has a simulation of triangles and squares. And when you click the Start Moving button, the triangles and squares rearrange themselves. This explorable is trying to demonstrate how is a simulation of how triangles and squares might move around depending on their biases towards one another. Another explorable is this one from the Seeing Theory website, where you roll a dice and they plot the average of the dice rolls and show that it converges to the expected value of 3.5. A final example of an explorable is a Brett Victor example. It's an old one. It's implemented in Flash, actually. And in this explorable, a skateboarder lets go of a merry-go-round, travels up towards a wall, and then bounces off the wall. Explorables are fun to play around with. And as instructors ourselves, we like to use explorables during class to illustrate a concept and also to answer student questions in real time. But they're also tricky to make. Most of the explorables that I've shown here so far require really specialized knowledge of JavaScript, of user interface programming, of JavaScript libraries like D3. And because of that, they're inaccessible to create for most instructors that we're interested in speaking with. So we asked the question, how can we lower the barrier to creating explorables? And Data Theater is our first step towards this. In Data Theater, we can recreate maybe what we call like a thrift store version of the Brett Victor explorable from the last slide. It looks something like this. So the red square represents a skateboarder, and the skateboarder travels up towards the wall and bounces off. I'm going to talk next about the Data Theater system we built and show you essentially how it works. So Data Theater has 3 panes. On the left pane is Python code. And the key difference here is that the Python code doesn't have to incorporate a user interface or graphics code. In this case, what we're doing is we're rolling 2 dice and taking the average of the rolls and then doing that over and over again. And so because of that, the Python code is relatively short and doesn't have to be intermixed with user interface code, as I would have to do if I were to try to implement this whole thing using Python. In the middle pane is what we call the Data Theater specification. It's a way to say how to create a visualization using a declarative JSON spec. And this is the custom part of Data Theater that we implemented. Finally, Data Theater renders the output live as a code and spec change. Although other explorables allow for many types of interactions, like some explorables allow you to move your mouse around to interact with whatever the simulation is. In Data Theater, we've made a simplifying assumption here and essentially only allowed the user to have one slider. When you drag the slider forward, we step through the code as though the code were running through a debugger. And as the code runs line by line, the variables in the code update. And when the variables in the code update, the visualization also updates to match. To illustrate how this works, I want to go through a quick walkthrough of making a simple explorable using Data Theater. So in Data Theater, we typically have some Python code in the left pane that we want to visualize. In this case, I'm just visualizing a rectangle. In Data Theater, what I do is I write some JSON, and this JSON is essentially like Data Theater specific. So I have to know that I have to have the type key and the X and Y keys in order for me to create this rectangle in the upper left corner of the output pane. What I'm going to do here is just to illustrate how this works. If I change the value of the Y to 50, the rectangle moves down by 50 pixels. And if I change the Y back to 0, it goes back up to the top left. What I can also do is link attributes of this visual object to variables in Python. In this example, I'm setting the text of the rectangle to be the first roll of my dice in the Python code. So the JSON spec can directly reference Python variables, and that's how we link variables in Python to visual attributes of the output. So again here, because the first dice roll was a 1, the rectangle in the upper left corner here now has a 1 inside of it. What I can also do is link visual attributes of the rectangle to Python variables. So here what I'm going to do is change the X value of the rectangle to be 50 times the first roll. Since the first roll was a 1, the rectangle now moves 50 pixels over to the right-hand side. Okay. What I can do now is drag the slider forward. And when I drag the slider forward, you'll see the rectangle move. The rectangle moves because the X value of the rectangle is linked to the first roll of the dice. And so when I re-roll the dice, the rectangle automatically moves to make sure that it matches the Python variable. So if the roll becomes 4, the rectangle moves over to the right. And when the roll becomes 2, the rectangle goes more towards the left. Okay, so that's the basic gist of how we create visualizations in data theater. We write Python code, and we write some JSON that links Python code to visual attributes, and then data theater hooks up and makes sure that the output always matches what the Python variables contain. For illustration, I can add another rectangle for a second dice roll. So again, here we're rolling 2 dice, so I can make another rectangle very much like the first one for a second dice. Okay, and then when I drag the slider around, now both rectangles should move because it updates both visual objects at the same time. Okay. So next I can add a box for the average of the 2 dice rolls. And data theater also allows us to implement collections of objects. So here what I'm doing in this picture is I'm keeping track of all the averages that I've seen before. And I'm going to render them using one box for every average. Essentially, we write JSON that tells data theater to loop over Python variables. So in this case, I'm going to loop over the averages list and render a box for every number inside the list. I can use the same X and Y to reference Python variables, and that allows me to kind of like visualize every single average that I've seen before. Okay, we also support scales. So in this case, what I'm doing is I'm applying a color scale from D3 to rectangles. So purple boxes are lower numbers and orange boxes are higher numbers. And we can use any D3 scale that D3 has available. Okay, so the main thing that I think is important about data theater is that we can save work linking together user interface code with actual explorable logic code by making use of the fact that data theater keeps the output in sync with the Python variables. As an example, I can return to the skateboard example that I showed in the beginning of this presentation. So in this case, the skateboard launches off the merry-go-round and bounces off the wall. In data theater, this takes about 18 lines of Python to implement on the left pane. In the middle pane, we use about, the entire JSON spec is about 30 lines long. And the final result shows the box as a skateboard, the red box is a skateboard, it launches off and bounces off the wall. Later on in Brett Victor's article about the skateboard example, he has an example where he changes the initial launch angle of the skateboarder and plots the time it takes to hit the wall in this picture here. And while we don't have the ability to add like custom sprites to our explorables like Brett Victor does here, we can also simulate this using a data theater. So in this case, I'm changing the angle of the merry-go-round as a skateboarder leaves. And on the bottom, I'm plotting the time it takes to hit the wall. It's a little messy, but beneath the merry-go-round here is a time plot. And this is supposed to be reminiscent of the time plot in Brett Victor's example. Okay. So this example, in addition to the example before, both of them were implemented in under 20 lines of Python, and each one required about 30 lines of JSON to implement. Using our own experiences as JavaScript developers or as programmers, we think that, or I think that, like re-implementing Brett Victor's example from scratch using JavaScript would take me at least 100 or 200 lines of code. And so I think So our goal here was to reduce the amount of effort needed to recreate these explorables. And we think that we can make use of data theater's affordances to reduce the amount of UI code needed. Okay, so that's data theater. And after working on data theater, I think I spent some time and thought a little bit more about like where data theater falls in the design space of explorable authoring tools. One way to divvy up this space is to place requisite programming knowledge on the x-axis and flexibility, like the expressive flexibility of the tool on the y-axis. And in the bottom left corner, we might have tools like whiteboards and PowerPoints for explanation or presentation. And in the upper right-hand corner, I place something like d3.js, which requires a lot of programming knowledge and even like programming knowledge specific to the library that we're using, like D3.
Sam, you should probably
Tangle. Yeah. Tangle.js I put in the same category. And around this, I have some other tools here. I think that data theater requires a little bit more than basic Python programming. But I think after making this, I'm a little bit more interested in knowing like how data theater can be used by instructors. And so some future directions for this work, I want to ask, like, what kinds of explorables do instructors wish to create? How might we further lower the barrier to authoring explorables for instructors? And perhaps in the far future, if creating explorable is as easy as creating a lecture slide, how will instructors teach differently? Thanks for your time. And that wraps up my presentation.
Cool, thank you, Sam. Sorry to call you to a halt there, but I'm conscious that we're slightly over schedule. Okay, so questions can either go in the chat or just raise your hand. Mary? Yeah, Mary Karen.
Hey, this is super cool. I never got around to learning D3. I still don't know D3, which I probably should. I make a lot of animations whenever I lecture on coding things, or I make custom code examples, which takes a lot of time. For this tool, it sounds like a really cool idea, but I want to know, how far can I go before I have to learn D3?
With this tool right now, I think it depends on what you're trying to make. So for example, as far as like visual objects go, we can pretty much only make circles and like ovals and rectangles using data theater at the moment. That was kind of based off our own experiences teaching, like where we mostly use circles and rectangles. If you want to do more interesting shapes, then that isn't currently implemented. I would say, so D3 gives you a lot of flexibility in terms of it can draw a map, for example, and it can give you other types of interaction modes besides just a simple slider. So I would say if that's what, I would say in this case, data theater trades off like expressiveness in the interaction for simplicity in the code.
Okay, I think Brian has a question.
Yeah, I was fascinated watching your talk and seeing what I take away as the key idea here is that, usually when people have tools for visualizing what their program is doing, the point is that they visualize the program for the sake of the algorithm of, like I'm trying to teach code or something like that. But in this case, it's for something else. It's like a different. And so you've taken it, you've said, the substrate of programming is my environment that we want to visualize. And you're going to only use the declarative mechanism as this kind of middle ground there. There's these declarative constraint connections. How did you stumble upon this idea to separate these things out? Because usually what people would do is they'd mix the display in with their Python code. Yeah. How did you get this idea? It strikes me as like it's really well.
It's a great question. I think personally, like I kind of cut my teeth like teaching data science before, and I would come across these demos and I'd want to like customize them for my own class. And so I looked into like making them. So I would open the source of these like explorables and look at the source code and kind of like the motivating thing for me here was that most of the time in these examples, you'd have like 200 lines of D3 like boilerplate, and then the actual logic of the explorable would be like 10 or 20 lines of like some like dice rolling thing. And so looking at that was kind of the inspiration for this. I looked at that and I thought, like maybe there's a way, maybe if we split out the logic of an explorable from the way the explorable renders, we can avoid some boilerplate and just save time. And that's kind of, that's essentially how this project began. Yeah.
Yeah, well, I really like how it turned out.
Thanks.
I have a kind of follow-up question, actually, unless anyone else has a question. So, yeah, I also really like this idea of kind of splitting out the presentation layer. So one challenge, I guess, that might come up in this setting, and so I'd be interested to hear whether you've kind of run into this. Suppose the thing you wanted to visualize was some kind of inner variable, sort of somewhere inside the computation rather than a kind of global variable, like a parameter to a function, say. Have you thought about how you might want to kind of expose that out to the kind of thing that you're visualizing? Or is it already possible?
That's a great question. I think it is possible, as long as the variable exists at some point during the slider, like as it slides through the code. So if like the highlighted line is within a function, I think Data Theater has access to all the inner variables at that point in time. But once like the debugger steps past outside the function, then we lose access to those variables, just as you would in a normal debugger. And I think those variables just like become null or something bad happens to Data Theater when that happens. So I don't think I've showed any examples of that.
Yeah, I guess maybe there are some variables that you can't even name because they don't have kind of global names. And I know Python has some pretty kind of wacky naming scopes, so maybe you can get access to things even when they're inside functions. But I guess if something's local to a function, well, I guess it depends when the Data Theater code is kind of evaluated. Is that what you're saying, that it's potentially in the dynamic context of some Python code, and you're free to just name a variable and kind of hope that it's in scope, essentially?
Yeah. So I think even in this picture here, on the left-hand picture, I have like the highlighted line is within a for loop. And I think like within that for loop, I would have access to like the looping variable, for example. But only if that variable didn't exist outside the for loop, then I wouldn't have access to it. So I could reference it in the JSON, but I think things would break if variables are undefined or none values.
Cool, thank you. Do we have any more questions? If not, then maybe we should thank Sam one more time. Right, our final talk is Brian Hempel, who is a PhD student at the University of Chicago, also one of the organizers of this workshop. Brian's interested in user interfaces for programming. And what he's going to show us today is a direct manipulation system for general purpose programming called MinipML.
All right. If the screen share resolution dies during the talk, interrupt me and let me know, and I'll turn my video off. All right, great. Hi, it's my great pleasure today to show you MinipML, which is first steps towards bimodal tangible functional programming. Now, the main inspiration of this work is Colonel Elliott's tangible functional programming system called Eros from ICFP 2007. So Eros provides this canvas on which the user manipulates the values of the program. So you're not manipulating program expressions, they're actually manipulating program values themselves. And these tangible values are usually functions with the function inputs on top and then the output of the function on the bottom. Right? And then these functions can be composed together. So you could use the output of one function as an input for another one. So right now, the output of this checkerboard function here is going to be used as the input of the image input for this intersection function over here. And when you compose these two tangible values together, you get a new tangible value where the output was used as the argument for one of the arguments for the other one. Right. So unlike a traditional programming environment in which you produce a program from top to bottom, these tangible values exist on a nonlinear canvas, allowing you to build up your program bit by bit. in whatever order you want. So what Elliot showed here is that there is a complementarity between functional programming and nonlinear editing. Because functional programming, there's no state. So you don't have to manage time, which means that when you're building up your program, you can say, oh, I need this thing. Oh, I need this other thing. I need this other thing. I need this other thing. And then you can figure out how to put them together later, right? And that's harder to do in a linear programming environment like a text buffer when you are at least naively building your code from top to bottom, right? So Eras is a compelling demonstration of nonlinear editing, but the values on the canvas, they're only values. There isn't associated code that you can easily read to see and know exactly how those values are produced. So what we really want, our ideal system, is that you would also have a text buffer as well. So you can have bimodal editing, where you can either plain text edit your code or directly manipulate the values to build up your program. All right. Now, manipulating output values to produce a program dates all the way back to the very first programming by demonstration system, Pygmalion, by David Canfield Smith. Right. So in particular, the canvas in Pygmalion showed values, and programs were created by drag and drop step-by-step demonstrations on those values. Right. Now, even recursion was supported, but the program was a movie over time. So editing was necessarily linear as you stepped through time. And there was no textual interface, so it was not bimodal. A more recent incarnation of these ideas is Josh Horowitz's Pain system from Live 2 years ago. Pain also centers the values in the program display, and you could also scrub through multiple examples to see how your code behaved on different inputs. And there was a few drag and drop interactions, but again, the interface was not bimodal, right? Bimodal programming, however, has been explored, but mostly for programs that produce graphics. Right? In the generic programming domain, Alvis Live offered students both textual and direct manipulation interactions to implement array iterative algorithms. And although, because it's an imperative environment, you necessarily have to manage time. So what we really want to do is try to provide a little bit more of a non-linear programming experience, and we're going to embrace functional programming to do so. So our prototype system is called MinipML, and it demonstrates a bimodal, tangible functional programming environment for a small, admittedly small subset of OCaml. So to show how MinipML works, we're going to tackle an elementary functional programming exercise, natural number addition. We'll define our natural numbers as either 0 or the successor of some other natural number. And then to add two natural numbers together, say we'll add the natural number 3 to the natural number 1. We're going to do this by recursion. So to add 3 plus 1, we will figure out what 2 plus 1 is. To figure that out, we'll figure out 1 plus 1 and 0 plus 1. Well, 0 plus something is just something. And then on the way back, we'll just add one successor to the front of our number every single time. All right, and we'll see that 3 plus 1 is 4. All right, so let's take a look. Right, where's my mouse? There it is. Okay, here is the MinipML interface. On the left here, this is just VS Code with a blank OCaml file. And then on the right is MinipML running in a web browser. It's watching the file on disk, and it will reload whenever the file changes on disk. So we'll start by defining our natural number type. So I'll say type nat is either 0 or the successor of some other natural number. Right? Whoops. And then when I save the code, the 0 data constructor and the successor data constructor appear in our toolbox over here. Right? Now we're going to make our plus function. We'll start by giving an example call to our plus function. Plus function doesn't exist yet, but let's make an example call. We'll call it plus, and we want to say, let's add 3 plus 1. So 3 is the successor of the successor of the successor of 0. And then 1 is just the successor of 0. And we will click set example. And what that does is it adds a current example definition into our code with our example call. And this is the code that's actually run. So it calls plus on 3 and 1. Right? There's also a skeleton of our plus function with 2 arguments. We can edit the code over here just as much as we could edit it over here. So we'll rename these arguments to A and B. That'll be a little cleaner. Save that. And then the body of the function right now is just this hole represented as a double question mark. Now in manipml, on our canvas over here, we can see our plus function. It has the arguments A and B. And we see how the code is actually being run. So we can see that A takes on the value 3 in our example, and B takes on the value 1. In the middle of our function is where the bindings would go. And we don't have any bindings yet, but this is where we hope that the nonlinear interface will eventually start to shine. You don't have to worry about ordering your bindings so carefully. And then the bottom here is the return expression of our function, which right now is just the hole, the double question mark hole. All right. So maybe we know in our head, yeah, I've got to use recursion. So I guess we'll just make a recursive call. We'll drag the plus function into the body of our plus function. And that will cause manipml to insert a new binding into our program. So now we have a +1 variable that comes from calling plus with 2 arguments. We don't know what those arguments are yet. They're holes. On the canvas over here, the call is also represented. And the white boxes next to the holes represent the values that are flowing through those holes. The program crashes as soon as it reaches the first hole. And because OCaml evaluates arguments from right to left, the first hole it hits is actually this one here, the second argument. And that crash is represented as a question mark, which is also the return value of our function here. OK, so now we've got, we think about it a little bit more. You think, OK, well, I probably need to call this plus with smaller numbers. So maybe I'll try and do 2 + 1. So I will take 1. I will actually drag the number 1 into the second argument. All right, and manipml inserts the variable b, and we can see that b is 1 there. Right? And then now I have a 3, but somehow I need to get that 3 to a 2. All right, so what should we do? Well, maybe we can find the 2 within the 3 and drag it out and put it in as the first argument here. All right, and then manipml realizes this manipulation by inserting a k-split into our code, this match expression here, which does a pattern matching to figure out what the form of A is. So if our A was the 0 form, it'll take 1 branch. This is, sorry about the formatting. Right? And if the A is the successor form, it'll take the second branch, and nat1 will be bound to 2 because the S matches the first successor, and then nat1 is the rest of the number, right? And so we can see that over here, we see that we've got a 2. To try and preserve some of the feel of nonlinear editing, we actually don't represent the k-split explicitly over on the canvas here. Instead, we use this funky symbol to indicate that out of A, we pulled nat1, and it has the value 2, right? Now, if we look at the arguments at the top of our function, we can also begin to see that, oh, our function is being called multiple times. It's being called with 2 + 1, 1 + 1, and 0 + 1. Oh, and in the 0 case, it takes a different branch. So some of our tangible values here are being grayed out. Right? OK. Now, if we go back to the top level, we can see that when we call this recursive function, it doesn't return. It still crashes. If we want to see where it crashes, we can click on the question mark. It takes us to the 0 case. So now we need to think about, OK, what happens when we add 0 to something? Now, for pedagogical purposes, let's just actually get it wrong. Let's say that 0 plus something is 0. Right? Now, if we go back to the 1 + 1 case, we'll look at it and we'll say, OK, to do 1 + 1, I need to do 0 + 1. And that returns, oh, no, it returns 0. I must have made a mistake. So let's edit our code. We can go back to the 0 case. And this time, yeah, 0 + 1 should definitely be 1. So we'll just drag 1 into our return value. And that uses the variable b for our 0 case branch. Right? Now, if we go and look at 1 + 1, we'll see 1 + 1 does 0 + 1, which is 1. Great. But we still don't know what to return in this case. Well, 1 + 1, and we have a 1. We need to be 1 more. So let's use our successor constructor, put it in the return hole. And what do we want to increase by 1? We want to increase the result of our recursive call by 1. So we'll use that as the first argument there. And sure enough, now we have 1 + 1 is 3. If we go all the way to the top, we can see 3 + 1 is 4. All right, it looks like we got it right. OK, so that was manipml. You can see how we used both direct manipulation and a little bit of text editing to create our function. All right, and the holes that we used allowed some amount of nonlinear editing. We could kind of build the program bit by bit and just kind of fill them in as we went. All right. And perhaps most notably, we were able to take a sub value and drag it out of its parent value and use that to induce a pattern match. So as we saw, the key visual structures in MinipML are these skeletons with the program expression shown on the top and the resulting runtime value shown on the bottom. Now, in the future, we might actually invert the priority here. So you, the programmer, could specify the value you want, and then that would tell a program synthesizer to search for an expression that will produce that value. So this would let you conduct programming by demonstration, or programming by example interactions within your program's execution environment. So besides adding such program synthesis interactions, we also want to try MinipML on some more practical examples besides just natural numbers. Right? Another challenge is that visualizations tend to produce a lot of space. One idea to help with this problem is once you have a function call and you've applied all of the arguments, we could hide the arguments and just show the result. So Pygmalion and Eros both do this. Right? And then right now in the demo today, all of our value visualizations were just text. It'd be great to have graphics for your values. So you could manipulate your tree that's as a tree. Right? And finally, our overall goal is to make programming feel like you have set stuff that you can touch, handle, and mold. There's a ways to go, but we hope that MinipML takes steps towards that ideal of bimodal, tangible, functional programming. Thank you for listening.
Brilliant, thank you, Brian. I've just seen one of the questions in the chat. So let's start with that question. This is from possibly a 3-year-old related to Ravi. What is the success? What is SSZ?
What is SSZ? So successor of the successor of 0. So that would be 2, the number after 0.
Okay, I'll let Ravi pass that one on. Jonathan, you're up next.
Very nice work, very foundational. So the problem with that happens often with these non-linear, as you're calling them, canvas sorts of approaches is showing structure. And you did call out there at the end something about tree structure. I didn't really catch exactly, but what happens if you have, like, let's say a nested conditionals, a nested match statement? How does that show up?
Right. Well, I have to admit that this is very much a happy path demo, so it doesn't yet. But what I was thinking is that is definitely one of the open questions. My current first thing I'm going to try is to actually let the pattern matches be somewhat fluid in the code, meaning that the synthesizer is much more willing to move them around and change them around. So on the canvas over here, when your dependency structure changes and you need different values out of a certain pattern match, it's more willing to just completely rewrite all your pattern matches from the root of your function, just to make it work. Because I said, oh, I need this value. Well, it's not in scope there, but we'll rearrange everything to make it in scope. Yeah.
So it's going to be a flat set of cases, and you're going to infer a logical partitioning. Interesting.
Yeah, that's what we'll try to start. Yeah.
Okay, thanks.
Okay, now we have a question from Mark.
Hello, awesome talk. This is really fun to watch you interact with this. I was interested in what you were mentioning about having something physical, this idea of tangible programming. And interestingly, I was just reading up this past weekend about tangible programming, which is where people are printing blocks that you then construct programs out of. Do you see this in any way? Like, I know obviously you have a different idea of tangible here, but is there some connection to make there?
I hope so. One of the thoughts I've had about tangible programming in places like Dynamic Land is there's a serious bandwidth limitation for the computer producing physical things. Right? So like if you had instant 3D printers that could instantly produce tangible objects, you might be able to get a little bit further. Because what I want to do here is I want to manipulate the values that are in the program, right? And you saw that the values that were in the program were changing instantly as soon as I added a new line of code, right? And you can't do that with blocks. You have to, somehow your tangible environment has to, you have to make blocks out of thin air somehow. I don't know.
Right. Interesting. Yeah, the tangible programming I'm looking at was using the code, like visual programming languages, and the code itself was the blocks. And here, I guess the output are the blocks, and it's sort of the opposite side of it. Very cool.
Right. Yeah.
Brian, I had a quick question. Just a boring one, actually. When you make the recursive call to plus and you generate a let rec, is that just the kind of default behavior then?
Yeah, because the idea is, if you want to, if you have a bunch of mutually recursive bindings, then it doesn't matter what order you put them in.
Right.
Yeah. So let rec is default.
Mary Beth.
Hi, this is super cool. So I may have missed this, you may have already said it, but usually when I see this sort of block programming interface, moving things around in this sort of software visualization, it's used in an educational setting. Would you use this kind of tool for like somebody's first functional exposure to like functional programming, and have you like tested this out with learners?
I don't know. I don't know. My dream is that it would be useful enough that I could use it myself for various things, but there's a lot to be done particularly on the performance side and scaling and making reasonable visualizations for extremely abstract values that your brain can do it, but how do you visualize that, and how do you do it in a space under space constraints on the screen? Yeah.
So I've got another question. I think you've already touched on this. I wasn't 100% clear. So if I kind of, I really like the idea that when you kind of pull out this sub value, it's a kind of case split on the argument in the code. Is there any kind of persistence in the synthesized code, or is each program just synthesized afresh, given a kind of new state of the output, if you like?
Well, I admit that this is Happy Path demo, so that's probably the only case split that works if you ever try it. But yeah, it's basically more or less what Jonathan was asking too, and I think, or related to his question, and I think the first version that actually handles case splits correctly is going to have to be regenerating them every time. Yeah, and hopefully later on you can have a bit more persistence of the code, because users get really angry if you start just moving their code all over the place.
Okay, we're almost out of time. I will ask one more question if nobody else has one. Is there a way of explaining easily the relationship between the double question mark and the question mark semantically?
Yeah, so double question mark is an expression, and then single question mark is a crash value, more or less. It's not even really a value. It's, oh, this is the part of the trace where it crashed. So yeah.
All right, fantastic. Thanks very much, Brian. And that's our last talk for the day. We kind of allowed ourselves 20 minutes to chat about whatever we feel like chatting about. We can use more of that if we like, but I imagine everyone's feeling pretty tired. So we kind of jotted down a few ideas, but absolutely feel free to kind of propose what you think is interesting to talk about. So one of the things I thought actually that's really sort of stood out today was the way a couple of themes were kind of kept recurring. So one was program synthesis, and the other was kind of data science. And I just wondered why that was, and kind of whether anyone had any thoughts on that and could take anything away from that. I guess a recurring theme to me is this kind of data-centric sort of way of thinking about things, or value-centric, like the pain interface that Brian just mentioned. And spreadsheets have that feel. If you think of traditional functional programming as about a kind of composing transformations, it's in the kind of point-free kind of world. You don't really see the data, you just have pipes that you compose together. And this is almost inverting that, where it's a kind of data-centric world where we're only interested in the values and the transformations are kind of hidden behind the values. And that seems to be very thematic. And I just wanted to throw that out there as in case anyone else wanted to comment or indeed comment.
I have a hot take on that if folks will indulge me. Hi. Yeah, I just jumped in for a hot take. I mean, to your question about data scientists, I mean, I think, Mary Beth obviously could talk about this a lot more, but I mean, just for myself and my students, I mean, my hot take is that I'm like pretty bored of targeting general programmers, right? It's like, maybe Jonathan can rant about this too, right? It's like, it's been 30 or 40 years or whatever, and general purpose software engineers are not going to adopt these sorts of more advanced visual tools because they're stuck in all this legacy stuff. And data scientists are just an exciting population, right? They come from different backgrounds. They don't have the preconceived notions and legacy that software development does, right? So like, one of my other students, Sean Cross, he does a lot with the R community, right? So it's like, the R data science community grew up in this parallel bizarro universe where, for them, programming is something really different than people who grew up in software engineering. And it's, they don't come in with the same kind of preconceived notions. So maybe these sorts of tools could see better adoption because they're like, oh yeah, like we don't have a big legacy base of what to build on. And also a lot of the, maybe Mary Beth can talk about this, a lot of the data science programming is more exploratory, more throwaway. So, they don't need to worry about like, oh, we have to support this gigantic 100,000 line code base. We could just write these 10, 20 lines and use maybe one environment to write some kind of code. And then maybe we can use another environment to write another thing and put it all together in this heterogeneous notebook format. So other folks should jump in.
I'll just add really quick, I've got barking dogs, sorry, to what Philip said. I think for me, why data stuff needs interaction and visualization so much is that it's just like crazy mad with hidden state. Data is like fundamentally hidden state. You write a program, you're like, what the heck is this data? Like if I have all the data of all the users on YouTube, what even is that? And like, how do I even negotiate like that enormous amount of data and all the possibilities that could be buried in there? And kind of exposing that in a programmatic way is really, really hard. So interactivity and visualization like allows us to look at something that's super hard to grasp or even fit in our heads, if that makes any sense.
Yeah, I think one thing that another thing I was struck by that kind of relates to what you just said and Philip's point about kind of data scientists versus general purpose programmers is, unfortunately, much of data science is kind of polluted by what it inherits from general purpose programming, through Python and so on. And a lot of what we saw today was about kind of dealing with things like side effects in code that really is crying out to be functional. And I'm kind of wondering whether there's a kind of data science 2.0 that's really a lot more functional and stateless. And we have these kind of notebook-like views of the intermediate states because we care, as you just said, Mary Beth, very much about these intermediate values. But we don't have to use lots of complicated stateful reasoning for understanding how we get from one state to the next.
That's fascinating. I liked how you used data science 2.0. That sells it. That sells the idea. You just got to put the 2.0 on there, and then people are going to start reading your blog posts, and the managers will come flocking.
One drawback, at least this is a hot take, sorry, that I've seen about functional programming in the context of data. So Google has this product that I'm not going to name that is like a super functional-ish way of doing data processing at huge scale. And it makes sense in terms of like, oh, we're going to add this function on top of function on top of function, and everything just like flows nicely. But it's really, 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 really hard to debug because in the functional world, everything is clean and nice and beautiful, and data is usually ugly and stupid and messy. And so when you have a super functional sort of like workflow, trying to like debug crazy weird state that you end up with because your messy your messy data is just really hard for people to debug. So that particular language is just very difficult to use, even though it's beautiful and functional, if that makes sense.
So stateless and functional is not enough. You have to make more affordances for the quirks of data somehow.
I think it's nice going after the sort of thinking of data science as a new kind of community of users as well, because they have a very different set of needs. You know, things like reproducibility and kind of communicability are much more important in data science than they are in regular programming. And I think that kind of forces us to think about the tools differently and the roles of tools and the roles of programs.
I guess like maybe even thinking more broadly, since we're on hot take land, you know, if we get bored of data scientists, what are other populations? You know, I'm getting bored of data scientists myself. So, you know, what's like, you know, what are other people who are, you know, not encumbered by legacy and who are up and coming and who are, you know, interesting populations? I mean, this really, on a serious, I mean, this kind of informs the next generation of grad students, you know, what they study and build tools for. I mean, I'm curious to hear people's thoughts on, you know, what other populations are there, people who do programmatically things that are not programmers or data scientists or, you know, engineers.
One perspective I'll add to that from my own talk was on live coders in the music and visual arts, which, you know, definitely has a different flavor than data science in that you know, there's less industry money behind it and perhaps less opportunity for grants. But I think you have that same sort of theme of this is a community that's pretty unencumbered by any sort of tradition. And there's also more of an exploratory aspect to what they do. But I think the biggest thing is it's very domain specific. Like data science is very domain specific, at least compared to software engineering, where you just, you know, you need to build code for whatever. When you're dealing with music or when you're dealing with visual coding or dance or whatever you're live coding, you are able to leverage so much of this domain specific knowledge into building interfaces and tools that can be so much more supportive than something that has to work, you know, for whatever C++ code you're writing.
Yeah, I think that's a really, really important point. And it actually applies to data science, I think, as well. It's, you know, I think the tools that people are using to do data science are actually too sort of domain general for actually a lot of the problems that people are solving, and that adds a lot of complexity into these kind of notebooks that is kind of redundant. It'd be interesting to think about, I mean, some of the stuff going on in, say, array languages and, you know, languages for more natively expressing the things that people are doing in data science. Perhaps the same could be said for visualization as well. Maybe there's scope for kind of more kind of intrinsically visual languages. I mean, the main thing you do with data is visualize it. So maybe we can make that more natively supported.
I could throw in, I'd like to concur with the feeling that data science, I've gotten tired of it. Just because I realize it's hopeless, because everyone's tied into these enormous infrastructures of, you know, Python or R code, and you know, or even Fortran or whatever, but you never get out of that stuff. So maybe we should be looking more towards the horizon, as I think Rolly, you asked. And one thing that continues to be a hot thing is the so-called low code and no code. People just have an unending need, and this has been going on forever. It just keeps getting renamed. You know, now it's no code. It used to be 4GL. For just simple applications, you know, stateful applications with a user interface in front of a database. And nowadays it has to be networked and social and so forth. A lot of, you know, the no code thing is already kind of burning out in the venture capital space, but I still think there's a lot of potential there for our kinds of solutions to be helpful. The question I always want to ask at the end of these is, of all the people here who've participated, we call this live programming, but is that the right word? Did that really work for you? Did that feel like it fit you, or is there another word, adjective, something that would better fit your interests?
Anybody want to comment on that? Any of the other presenters?
I will say that I feel like my own interpretation, I was talking about live coding in my own talk, and that's a term that is left very ill-defined purposely. And I get a similar sense from live programming, which is actually something I really appreciate, that it keeps the door open. So I feel like it's hard to point to something and say, oh, that's live programming and this is not live programming. Aside from maybe, some extreme cases, but, once you're in that middle space where it's sort of like, there's a lot of space where we can work here. I think this is, whether or not there's a better term, this idea of having some space that you're working that has that flexibility to say, okay, it's, we're sort of in that space. There's no real edge to the space, is really helpful for me. To be able to work on live coding and then connect it, say, oh yeah, this is kind of like live programming, sure.
Last week, I gave a talk about live programming to a community outside of live, and they thought I'm just going into an editor and code something in front of compiler people. And that was not what I was doing, obviously. So maybe we should come up with a different name. Maybe it could be responsive programming or something, rendering anything else unresponsive. I don't know. Just an idea. Improv programming.
Yeah. That's fun. Yeah. Some sort of construction. I will say one benefit of the word live is that it has a connection to human life, and a lot of other words that you might use in this space would be more associated with physical material utility rather than something more human, closer to the lived experience that isn't just robotic.
Well, when people ask me what I'm working on, I sort of at the dinner party, cocktail party kind of setting. Remember when we used to do those things? I call it humane programming. And I say, trying to make programming more like a spreadsheet is the other thing that explains it to people.
Yeah, or the convivial computing salon uses the word convivial, which is, again, its idea of life.
I just read a book, The Other Side of History. Maybe this is the other side of programming. When the history was mainly about only the kings and all those conquerors, and the common people were the other side of history.
Maybe we'll only kind of have succeeded when it's no longer called programming at all. When we've forgotten that there's programs, there's just stuff that we kind of manipulate and work with, and it kind of, it's like a medium that we can tangibly manipulate.
Well, I guess speaking on that theme, I mean, an idea for future years is, if there's more time, is to actually do some live programming, right? So like, taking some of these systems that folks have presented and, and just trying, I mean, obviously it would be hard for other people to try it out if they're prototypes, but just having the authors themselves just actually try it out, and people make suggestions and be like, oh, can you actually, build a more sophisticated visualization with this, and kind of scratching your head to figure out how to do it. And maybe if there's kind of parallel rooms or something, then, we can parallelize that time. That could be kind of a cool experience, right? So instead of, 5 hours instead of just a lot of talks is, we'll spend, the 3-hour session where the authors actually just are at their systems and doing stuff, and then people can come in and talk with them and stuff. A lot of industry conferences have these, I guess they're more tutorials, right? They have like, a 3-hour tutorial learning how to use pandas or whatever. And it's really just people in front of their computers just trying it. So that could be kind of cool because, these systems are, we're giving talks on them, but it would be cool to actually just see them at work. Just giving folks more work to do. But
yeah, live music programming is full of, improvisation, and where you can just think, oh, I'm going to do this and then do it. Or if someone can, I don't know, shout something out and describe it to you musically, then you can go and do it. And I guess that's the dream, to be able to just, I want suggestions from the audience about this, what software to make in front of your eyes in less than 10 hours.
Yeah.
Fashion, and to be able to just do that.
Yeah, I don't think we can get to as much real time for these things like that we can in music, but still, like if there is, a 2 or 3 hour slot and people, come in and make suggestions, I think then we'll get I think people like even audience members will get a much better feel for what these systems can do, right? And I think it'll help the authors out as well, thinking about, people using it by proxy almost, right? It's like, oh, wow, I want to make this kind of visualization with your thing. Like, how could we try to do a simple form of that? That'd be cool.
I don't know about you, Philip, but if I spend 10 days making like a cool new prototype of a programming environment, I can break it in about 10 seconds.
Well, that'd be fun too. That's
session would be very short.
Whatever happens is good. So
yeah, I suppose one of the things you could do is you know that your programming tool has all these holes in it, and the idea isn't to kind of show up the presenter, but maybe just to find out how expressive it is, even in spite of those holes. What can you still do? Because a lot of the time you can work around.
And the glitches are cool too, right? I mean, there's this whole like glitch, world of, people doing live coding or other stuff and showing glitches and, in graphics programming and in music and stuff. And that's like art in itself. So I'm just throwing more hot takes out there.
And those live programmings and dynamic programmings tend to be not fall apart as a C program falls apart when it hits a null pointer. Then the whole environment crashes, and in the dynamic system, you get a debugger, or it continues and says, didn't know what to do, just continuing. So it does not fall apart so easily, I hope so, Mary.
So in Brian's system, you get a question mark, right?
Yeah, although I was about to say that OCaml has type erasure when it compiles, and that's just, I may have to ditch OCaml because it's very, very hard to deal with it.
Okay, we've used 20 minutes, so how about we take a break, because I'm sure people have other things to do. And we're going to reconvene at 3 p.m. Central Time, which is 9 p.m. GMT, in our GatherTown virtual pub, which has a virtual pool table. And there's a pub quiz, which people are welcome to join in with or not as they see fit. And Brian and I will definitely be there, and I hope as many of you will be there as can be. So thanks everyone for attending. It's been a really fun workshop.
Yeah. Thanks for organizing it.
Yeah.
Thank you.
Thank you.
Yeah. And if you didn't sign the attendance sheet yet, I did put the link again. We just want to have a record of that. And I'm probably going to just jump in the GatherTown right now, just so that if you want to just be there and sit there, I might not be active, but
I'll be there.
Yeah, where's the virtual public? Let me get that in the chat. It's, if you go to liveprog.org, it's on our program there, but I'll put in the chat in a second. Copy. Oops, that's not it. That's the link text, link address. There we go. That one of these times. Victory. All right. All right. Well, I hope to see you guys there, and thank you all for attending.
Thanks, everybody.
All right, I've stopped my recording. You can probably do the same. Well, unless you stepped out.